populations such as elder people and children. Heat waves can result in economic losses due to impact on agriculture, infrastructure, energy demand, and labor productivity. These concerns emphasize the critical imperative for a detailed understanding of underlying science of heat waves or warming environment and associated challenges. Therefore, interdisciplinary collaboration involving meteorologists, climatologists, public health experts, economists, social scientists, etc., at local, national, and regional level is essential. Apart from it, policy measures targeting the reduction in greenhouse gas emissions, urban planning, heat resilient infrastructure, and public health adaptation are crucial for mitigating heat wave impacts. We are honored to have all of you together on this forum where we are confronted with a dual mandate to deepen our understanding of the scientific intricacies underlying heat waves and to grapple with the multifaceted challenges. By integrating scientific knowledge with effective policies and community engagement, we can strive towards a more resilient and sustainable future in the face of escalating heat wave risk. Without further delay, let us officially inaugurate the National Symposium and set the stage for an enriching and memorable experience ahead. To welcome our esteemed guests and dignitaries on the dais, firstly, I would like to request Dr. Satyaban Bishoy Ratna, Secretary IMSP, to extend a warm welcome and felicitate our today's chief guest, Professor Shekhar Mande, Distinguished Professor, Bioinformatics Center, Savitribai Phule Pune University, and former Director General, Council of Scientific and Industrial Research. Welcome, sir. We welcome you, sir. Now, I would request Dr. Archana Rai, Joint Secretary, IMSP, to welcome and felicitate AVM Dr. Ajit Tyagi, President, South Asian Meteorological Association and former DG IMD. I welcome you, sir. I once again invite Dr. Satyaban Bishoy Ratna to welcome and felicitate Dr. Rupa Kumar Kolli, sir, President, IMS National Council. Now, I request Dr. Archana Rai to welcome and felicitate Dr. Satyaban Bishoy Ratna, Secretary, IMSP. We welcome you all. अब हम आज के कार्यक्रम की शुरुआत करते हैं दीप प्रज्वलन के साथ.
डॉक्टर आशा.
यस. यस सर. नेटवर्क कनेक्शन disconnected. Sir, we are audible.
Dr. Asha, you have to welcome Secretary.
Yes.
Secretary sir is online.
Yes, sir. Yes, sir. Sorry. I welcome on this forum Secretary MoES, Dr. M. Ravichandran, sir. We welcome you, sir.
Thank you.
I also welcome Chairman IMSP and Head CRS, Shri K.S. Ushalika, sir. We welcome you, sir. Please accept my apology for these kinds of issues.
Yeah, that's okay. Okay, we go ahead. Krishnan sir, you have to welcome.
Good morning, respected Secretary, Dr. Ravichandran sir, Dr. Hosalikar ji, IMSP Chair, all the dignitaries on the dais, Dr. Mohapatra ji, and all the Bhan and all the esteemed colleagues. I'm sorry I'm unable to join because the monsoon mission meeting is going on. So I'm very happy to welcome you all to this important event on the understanding the science of heat waves. It is very timely and it's a very important. This is nice to know that.
Sir,
excuse me.
Yes, sir. Sir, actually, we are going to start our program first with lightning of lamp. So,
okay.
Sorry for
that. Okay. I'm sorry.
No, sir, it's fine.
Sorry.
So, आज के कार्यक्रम का शुभारंभ करते हैं दीप प्रज्वलन के साथ। मैं मंच पर बैठे हुए सभी माननीय गणों से निवेदन करूंगी कि कृपया वो आगे आए और दीप प्रज्वलित करें। आप सभी का बहुत-बहुत धन्यवाद। Now, I would request Shri K.S. Hosalikar, Head CRS IMD Pune and Chairman IMS Pune Chapter, to deliver a welcome address.
Thank you, Dr. Asha. And first of all, as a chairman, IMSP, kindly excuse me for the delay in starting of the program and bit of inconvenience while the opening address. So kindly excuse. So a very good morning to all of you and a warm welcome to the second day of the workshop, which is on the National Symposium of Understanding the Science of the Heat Waves, being organized by India Meteorological Society Pune chapter, jointly with IMD, IITM, and Ocean Society of India Pune chapter is joining first time. Indeed, with the super response yesterday for the monsoon workshop and then monsoon workshop, this second day also I'm expecting to be something very special for all of us. That is on the heat wave. And as the India Meteorological Department in the beginning of March have already given the seasonal forecast that it could be, the temperature could be above normal temperature for March, April, and May, and there is a possibility of the heat waves also in many parts of the India. I think this particular workshop on the heat wave, understanding the science of the heat wave, and bringing this type of awareness and sensitivity with the help of experts and key players is a apt time, and I'm really very thankful that we could to all the people who are involved in this, in bringing to this level that we are able to gather here and talk about it. So before we go ahead with the program, let me the do my responsibility as assigned. On behalf of Indian Meteorological Society Pune chapter, I first welcome our chief guest, Dr. M. Ravichandran Saab, Secretary MoES, under whose guidance we all are working. IMD, IITM, NCMR, WF, INCOIS, all MoES institutes are working, and most of them form, the part of the Indian Meteorological Society. So he has been very kind enough to agree with a very, very short notice to come on this program online. And sir, we are very thankful to you and your support to Indian Meteorological Society Pune chapter and overall IMS activity also has been very helpful us and very guiding to us. On behalf of IMS, I welcome you here, and we are very happy to have you here. Thank you very much, sir, for your presence. I also take this opportunity to welcome our very close associate, Professor Shekhar Mande Sahab, who is currently professor at Pune University, former DG CSIR, and of course he was also there as a secretary MoES for some time. And his guidance and his support being in Pune for various activities of IMD, IITM, and IMS also has been very, very helpful. And as we are talking of the heat wave, I know that his core science, core subject, is the molecular cell biology. So probably, there would be definitely a lot of scope to understand the heat wave and the health impact in the coming time at a different level, or maybe at the inner levels that we may be thinking about it. I take this opportunity to, sir, we are very fortunate, Shekhar Mande sir, to have you, and I welcome you to this second day of the workshop also. I also welcome Dr. Krishnan sir, where we are sitting today in this Medud auditorium, very, very, very beautiful auditorium with all the latest infrastructure facility available and the campus of IITM. I think Krishnan sir has been very, very kind, and to share and to extend all the facilities that are available without with so ease that sometimes we feel that we always are in our own house. So Krishnan sir, we are very thankful to you, and your support to IMS has been also very tremendous. IMS Pune chapter is one of the will be always thankful to IITM Pune, and we are very happy to have you here on this day, and we would like to hear from you also. We also have here Dr. Ajit Tyagi sir, former DG IMD and the president of SAMA. It gives me great pleasure. Yesterday I came to know that the WMO Secretary General has issued a letter of appreciation to the President SAMA, and indeed it's a great achievement for SAMA, and it's a great achievement for all of us. I think this is what probably a society like SAMA and Indian Meteorological Society and Ocean Society of India are capable of doing it, and the potential that have it. So Dr. Tyagi Saab, we are very fortunate to have you here, and I welcome you on behalf of IMS Pune chapter. We also have Dr. Kumar Kolli here, and of course Kumar Kolli doesn't require any introduction much. He's a part and parcel of Indian Meteorological Society, and also he has been very closely associated with the Pune chapter activity. A very renowned scientist at the WMO and IITM, and his guidance for NFCS and other activities have been very helpful for IMD as well as for IMS also. So, sir, I welcome you here. And before I end my talk here, let me welcome all the senior dignitaries, scientists, students from the different parts of the country who have come here and who are gathered here, to attend and to listen and to exchange their ideas about the science and the heat wave is something very nice. I call it as a festival or utsav, And at the same time, I congratulate all the uh, all the dignitaries who are going to get recognition from Indian Meteorological Society for their special work in their field. So I congratulate all of them, and I also congratulate my Pune chapter for making this possible to at this level. And kindly excuse me that I'm coming online. And once again, I welcome all of you. Thank you very much. And I stop here.
Thank you so much, sir, for your warm address to our gathering. Dr. Kumar Kolli, President, IMS National Council. He had contributed to the development of WMO, WHO guidance on heat health early warning systems, published in 2015. He is one of the founding members of the management committee of the Global Heat Health Information Network. Earlier, he had also served as a vice chair of WMO Standing Committee on Climate Services. Now, I would like to invite Dr. Kumar Kolli, sir, to throw some light on this national symposium.
Thank you, Asha. Good morning, dignitaries on the dais and online, and friends. At the outset, let me compliment and congratulate the IMS Pune chapter for selecting this topic for the National Symposium, which is really attaining global importance in terms of the excess heat and the exacerbation of the problem by the ongoing climate change. I'm also acutely aware of the increasing frequency and intensity of the heat waves that Asha has highlighted earlier. And in fact, this problem has been gaining increasing importance globally, as you can see from the fact that for the first time, the UN Secretary General has appointed an extreme heat advisor at a very high level. So this is how excess heat is actually being recognized as a major socioeconomic problem that we have to grapple with. And at the same time, we have to keep in mind that heat waves are not just spikes in temperatures. So they have many facets in the way they impact our lives and the ecosystem. And as we are already witnessing the devastating consequences of extreme heat events, it becomes imperative for us to take proactive measures to mitigate and adapt to these challenges. Through this symposium, we aim to foster interdisciplinary collaboration, which is essential, and exchange of ideas, and to enhance our understanding of heat waves and to develop effective strategies for resilience. In fact, I have had the opportunity, in fact, the very first assignment that was given to me when I joined WMO was to attend a climate impact on health event organized by the WHO. So that is when actually I really got in touch with the health community and how they actually understand and apply heat wave information in their activities. And from there, as Asha has mentioned in the introductory remarks, we went ahead with a strong collaboration between WMO and WHO, which resulted in a well-known guidance document on heat health warning systems. And subsequently, as again Asha has mentioned, I was part of a group which established the Global Heat Health Information Network. In fact, I'd like to use this opportunity to advertise that network. So you can actually go to the website and look for www.ghin.org. So it has lots of information on heat waves and various aspects of heat wave impacts. And they have also recently opened a LinkedIn group, which you can join and actually share your experiences. So in that sense, I think this this symposium, and not only that, in fact, we are on the verge of entering the heat season in India. I think it's very pertinent that we have this symposium to discuss the impacts of heat. And we also have in our midst that a number of eminent scientists and experts who are looking at the role of heat waves from various types of angles. And it's important for us to consolidate all that capacity and address this challenge in a joint and concerted manner. So I hope this symposium will help us to know each other better and actually complement our work in a way that can help us to deal with the heat waves in the best way possible. And in fact, as we discussed as part of the consultations at the global level, it is increasingly being recognized that every single death, primarily due to heat wave, can be prevented. So that is how we can actually make a real impact in properly addressing the heat wave problem and finding adequate solutions. So with that, I once again welcome you all to this very important symposium and look forward to very interesting discussions and way forward. Thank you.
Thank you so much, sir, for highlighting the importance of this national symposium and also sharing your work experience with WMO. Now, I would request Dr. R. Krishnan, Director IITM, to address the gathering. Prior to taking charge as Director IITM, he headed the for Climate Change Research. Under his leadership, this center developed the IITM Earth System Model, the first global climate model from India that contributed to the Coupled Modeling Intercomparison Project, Phase 6, and the IPCC 6 Assessment Report. We welcome you, sir.
Yeah, thank you, Dr. Asha. First of all, respected Secretary, Dr. Ravichandran ji, today's chief guest, Professor Shekhar Mande, our guest of honor, Dr. Ajit Tyagi Saab, former DG IMD, for participating in this event and gracing this occasion. Sri Hosalikar ji has really set the stage for today's talk, and also Dr. Rupa Kumar Kolli on this heat waves. It is becoming a very, very important topic. It is already affecting us, and already we are experiencing the impact of heat waves right now as we speak. So, and the forecasts are also indicating that the heat wave is going to become, we can experience more heat waves this season. And I also looked at the speakers today in the agenda. It's a very impressive set of talks on the heat wave trends, climatology impacts, heat action plan, and also the patterns of heat waves, atmospheric blocking. So both the science and the understanding component, and also the health impacts, and also various interventions, marine heat waves, the seasonal forecasting. So these are all very, very important. Land, soil moisture impacts on the land atmosphere interactions. So it is a very well chalked out program that I can see, and I'm really hoping that the deliberations will be very productive and fruitful. And so I look forward to these very important discussions in today's meeting, and I welcome you all. I am sorry that I am unable to be physically present there due to another meeting here, and sorry for causing some embarrassment in the beginning. So with this welcome, with this brief introduction, I once again welcome all of you. Thank you very much. Jai Hind.
Thank you so much, sir, for your encouraging words and your kind support in hosting this symposium at your esteemed institution. Now, I would like to invite our next guest, AVM Dr. Ajit Tyagi, President, South Asian Meteorological Association and former DG IMD.
Thank you, Asha. Dr. Ravichandran, Secretary, MoES, Professor Mande, the Chief Guest of Honor, Dr. Rupa, Kolli, Dr. Krishnan. At the outset, let me thank Pune chapter to have invited me for this important event, the National Symposium on Heat Waves. Without sounding alarmist, let me bring out that February 2024 was the warmest month of, and the last 9 months from June onwards have been the warmest months. If we look at the last 10 years, the last 8 years have been the warmest months, warmest years in the recorded temperature data, which is available from 1850 onwards. Now, this is already raising alarming bell, which has been now recognized everywhere. And that sweet threshold of 1.5 degrees centigrade has already been crossed in the month of January and February. So what we used to think that we'll be able to manage by 2030, 2040, keeping temperatures within rise of 1.5 degrees centigrade is already taking place. So this is the reality, and its manifestation is already taking place. We all know in last decade how the rising temperatures, the 40 degrees centigrade is becoming normal in many countries, the European countries, Japan, and you'll be surprised to know that last decade the heat wave affected the Siberia, the northern parts of Canada, so which we could not imagine some years back. Now, this scenario, we know the climatology has brought out here that yes, frequency, intensity, duration, all these factors of the climate heat waves are increasing, and they are being impacting to the, we are as of now talking only of the human health, but many other sectors. Now, as far as human health is concerned, you may be knowing that in 2003, Europe, 70,000 deaths took place because of the impact of heat wave. In India also, many years we did have deaths going into the thousands. In 1998, Odisha had more than 3,000. In 2015, Andhra had more than 2,000 deaths. And so this is not that something new, though climate conditions of India that we are adapted to a large degree to the heat waves. But with the rising temperatures, if they continue, it's going to be challenged to manage the heat waves in the same fashion. Now, so this is a big challenge, and we have to understand science as far as forecasting of temperature is concerned, and the realization of heat waves. India Met Department has been issuing warnings of the heat waves based on the maximum temperatures for last 50, 60 years. And even with those warnings, until unless we bring administrator and public awareness, the deaths used to take place. But in last 10 days, 10 years, when the NDM started and the heat action plan started coming up, there has been significant decrease as far as the deaths are concerned because of dissemination of these timely warnings and the action taken by on the ground by the administrators and public awareness. So, so this is very important. But now there are two challenges which are emerging. Is one is with the urbanization, the urban heat islands, which are taking place and which I am sure Rajashree will cover in her presentation. They are going to be a real problem for all of us. It will also affect the microclimate of the cities and the night urban heat islands. The comfort which normally in the night time is there will not be available. So prolonged heat impacts will be felt by the general public. So this is another. Second thing is going to be within the city. There is going to be wide variation. So a common warning for all places will not be sufficient. We have to go targeted warnings up to a ward level, which I am sure Mahavir is going to cover to some degree in his presentation. So these are the challenges. Second thing which is there as far as science is concerned is the marine heat wave. Now, this also have been recognized in the recent years that is directly affecting the marine life, but also its interaction with atmospheric processes is going to impact the the weather and climate at the regional scale positively, and maybe the global scale. So these are the challenges with the science we have to now address, apart from the general heat wave warnings and its impact. As far as forecasting of temperature is concerned, I think we are very well placed. The IMD issues warning right from the season to the nowcast. So these forecasts and warnings are available, but then we have to go in for much more refined warnings based on the heat indices, which really incorporate the humidity, the winds, and the radiation and many other factors. So this is another important challenge. And the biggest challenge is going to have thresholds. See, uniform threshold for entire country is not really um, applicable. We know this is, but then we have to come out with thresholds. As far as health thresholds are concerned, with the health data, we are able to address to some cities, but is not being done for all the cities in the country. So it should be done. But what is more important, we had a national workshop organized by the NDMA last month. The impact of the heat wave is beyond human health. You see, human health, yes, no doubt is important, and we should have zero deaths. But its impact on various socio-economic sectors, infrastructure, energy, agriculture. So these all are coming up in a big way, and this was brought out. And we, as a meteorologist, have to work with these domain specialists to bring out the warning systems for these and give such advisories to people to take necessary. See, I am from the aviation sector. I know long back in high altitude airfields like Leh, after 10 o'clock, no takeoffs were permitted because the temperature in high altitude didn't permit with the length of runway to aircraft to take off. So this is where the practical impacts are going to take place. Like many other sectors, they brought out in the rail, the road transportation, how the high temperatures are going to impact. So we have to now work beyond the human health, also in all these sectors. And I'm sure the socio-economic things also will be covered by the Professor Das Gupta. So this is good that we are now, one thing is no doubt we have to improve our warning systems, which continues. Then we have to work on indices which are there, work on thresholds, and thresholds for each sectors are to be worked out with partners which are there, and also to make people aware, the administrators aware, because we do issue a warning. IMD has been issuing warnings for last 50 years. But before this heat action plan came into force, nobody used to take it seriously. It used to be a normal bureaucratic exercise. We used to issue warnings. It used to be there. Nobody used to take action. But now with heat action plan, these are being, so this is very important that administrators, public, municipal corporations and other general public is made aware of these, the impact of the heat, and the necessary precautionary and the preparatory measures are taken. So I'm sure many of these things will be taken up in this workshop or national symposium, but these are the some of the issues are for the research, it's for the scientific community to address, particularly the urban heat island, its impact, and the marine heat waves, and the thresholds for various sectors. So with these, my comments, I once again congratulate India Met Society Pune chapter for organizing this national symposium on a very important topic at a very timely fashion. Thank you so much. Jai Hind.
Thank you so much, sir, for emphasizing the various impact of heat waves as well as sharing the inputs on early warning systems. A souvenir cum extract volume has been prepared for the symposium containing all the abstracts of the invited talks as well as oral and poster presentations to be presented in this workshop. Now, I would request Secretary MoES joined online the symposium, and our chief guest and all the dignitaries on the dais and the scientists present virtually to kindly release the abstract volume. IMS Pune chapter takes pride and privilege to award certificate of recognition to some scientific people for their exceptional contribution in climate and society fields. So, the first certificate of recognition to Dr. Kumar Kolli. He is the president IMS and worked as vice chair of WMO Standing Committee on Climate Services, who has been actively supporting the expansion of the activities of IMS. He has also been associated with the IMSP for over 4 decades. So IMSP is delighted to award this recognition to Dr. Kumar Kolli for his continued efforts for IMS and his contribution to strengthen the climate services in the country. Now, the next certificate of recognition to Ms. Nidhi Jamwal, who is a senior journalist based in Mumbai, Maharashtra. Along with the regular special reports on weather and climate, she has been reporting on rural India, traveling extensively to the hinterlands for more than 25 years. IMSP is delighted to award this recognition to Ms. Nidhi Jamwal for her continued efforts in bringing out reports on climate and its socio-economic impacts, especially in the rural India. Now, the next certificate of recognition goes to Mr. Somnath Mahapatra. He is a scientist at IITM Pune who has been actively involved with Monsoon Mission, ICMPO, IMPO, Savitribai Phule Pune University, and IMSP for a long period. He has been the managing editor of the Bulletin of IMSP since 2018. IMSP is delighted to award this recognition to Mr. Somnath Mahapatra for his continuous support to IMSP for a long period of time. Now, IMS Pune chapter proudly announces an appreciation and recognition to Dr. Satyaban Bishoy Ratna. He is scientist at IMD Pune and recently selected as a member of World Climate Research Program, Clever and GWEX Monsoon Panel, and Clever Climate Dynamics Panel. IMSP is delighted to award this recognition to Dr. Satyaban Bishoy Ratna for representing in these panels, which are working to advance our understanding of climate dynamics, including monsoon variability and improving prediction across different spatio-temporal scales. Now, the next certificate of appreciation and recognition to Mr. Sikandar M. Jamadar. He is a retired meteorologist from IMD Pune who has represented IMSP in the IMS National Council and very active for activities of IMS and IMSP for a very long period. IMSP is delighted to award this recognition to Mr. Sikandar M. Jamadar for his continuous support to IMSP for a long period of time. Now, IMS Pune chapter proudly announces an appreciation and recognition to Dr. Rajiv Chattopadhyay, scientist at IMD Pune and IITM Pune, who has represented IMSP in the IMS National Council and contributed to various IMS and IMSP activities. IMSP is delighted to award this recognition to Dr. Rajiv Chattopadhyay for his continuous support to IMSP and for contributing to science popularization activities in different forums. We congratulate all the person who got the appreciation and recognition from IMS Pune chapter. Now, I would like to give a brief intro about our guest today, Professor Shekhar Mande, Distinguished Professor, Bioinformatics Center, Savitribai Phule, Pune University. He is an accomplished scientist and researcher in the field of bioinformatics and structural biology. He was the Director General of the Council of Scientific and Industrial Research India and the Secretary of the Department of Scientific and Industrial Research, Ministry of Science and Technology during October 2018 to April 2022. Throughout his career, he has held various leadership roles and contributed to numerous research projects, earning recognition both nationally and internationally for his work. He was awarded with the Santi Swarup Bhatnagar Prize in 2005 for Science and Technology, the highest science award in India in the biological science category. I would invite our chief guest, Professor Shekhar Mande, Distinguished Professor, Bioinformatics Center, Savitribai Phule, Pune University.
Thank you, Asha. We are already running out of time, and I recognize that Ravi has been online and giving precious of Delhi. He probably is counting his time very quickly. So my good friend Ravi, Secretary of Sciences, who has joined online. Two other good friends, Krishnan and Hosalika, also have joined online. Present on dais, Dr. Kolli, Dr. Tyagi, Dr. Bhan, friends and colleagues in the audience. In about 2 to 3 sentences, you will realize from now that I don't understand anything about heat waves, not the least about urban heat waves and climate change and other things. I have been principally a biological scientist. I mean, although I was trained in physics originally, but all my career I have only followed up biological sciences, and a deep interest has been in analyzing data from the beginning of my career, the large biological data. And we have applied variety of different techniques in the understanding of biological data that related to health, that related to other biological principles and so on and so forth, including machine learning and things like that. And in recent times, for example, when the pandemic broke out in my lab, we tried to understand different parameters that affect the mortality due to the SARS-CoV-2 virus in COVID-19 time. And while analyzing the data, at times one actually comes up with some very startling observations which may not have been foreseen by public health experts around the world. And one such observation was the fact when we analyze data, and it was not a very hi-fi machine learning or deep learning technique. We did simple analysis of about 100 odd parameters, and one of the most simplest of the techniques called linear regression. And we were able to show that the correlations of mortality in different countries was related to certain parameters that were not foreseen earlier. And the basis of this particular observation was that people in the richer places, richer countries, especially Western Europe and North Americas, the mortality rates seem to be much higher than people in the global south, that is in Africa, Southeast Asia, South Asia, and so on and so forth. And the difference was very stark. And with the analysis that we performed, we actually come up with an hypothesis that those who see infections from their childhood because of the not very highly clean atmosphere around them, their immune system is better trained if any new infection were to break out. There's been a lot of criticism, of course, of our data, but the data is quite solid. All the sources of data have been made public, and anyone could repeat the analysis, and most people would come to the same conclusion. So the thing is, what we call as the hygiene hypothesis is not something new. Hygiene hypothesis has been known earlier, that people living in less hygienic places are better trained in their immunity to face new infections. Well, that's the hypothesis that we actually came forward. And one paper is still under consideration at this moment as we speak, what we have done. Now, the point of telling this is that in very complex matters such as public health, climate is another example where the complex data are available. And because a lot of longitudinal data has been made available in the last few years, but it's imperative that many of us actually start analyzing data which is very disparate to try to see causations and correlations, if any, of this particular data. And I'm sure some of you would have already been doing this. Some of the latest techniques in data analytics, for example, the use of large language models, are also becoming very popular around the world. It requires a lot of computational resources, LLMs particularly. And in biology, we have been especially benefited by some of the LLMs that have been used. For example, many of you would have heard of Google's tool called AlphaFold, which predicts what is called as protein folding problem that appears to have been solved. And we're expecting the Nobel Prize for this to be announced to the Google scientists anytime now, this year, next year, or the year after that. So the large language models are already making an impact on many of the things. It's not that large language models don't have any kind of drawbacks. They also suffer from things like hallucinations and so on and so forth. But nonetheless, some of the techniques of data analytics, large data analytics, deep learning, large language models, and so on and so forth, I'm pretty sure some of you have already begun working on them. And I'm sure they will actually bring a lot of benefit in trying to understand the problem that you're addressing here and all you have gathered here to address these particular problems. I'm sure you will have great deliberations in the next 2 days in this particular workshop. I don't want to take too much time as I see Ravi getting kind of restless. And I wish all of you the very best in the next 2 days for the workshop. Thank you all very much.
Thank you very much, sir, for your insightful remarks and encouraging words. Today, we are privileged to be joined by the esteemed Secretary of the Ministry of Earth Sciences, Dr. M. Ravichandran. His expertise across various domains of earth science is truly commendable. His wealth of knowledge and extensive experience will undoubtedly deepen our comprehension. Now, I would warmly invite respected Secretary Sir to kindly deliver his address.
Thank you. Thank you. Professor Shekhar Mande, my good friend and former Director General of CSIR and presently Professor at Savitripula University, Pune University. Dr. Ajit Tyagi, former Director General of IMD. Dr. R. Krishnan, Director IITM. Dr. Rupa Kolli is also my good friend, President IMS, and Dr. Kotharkar, Chairman IMS Pune Chapter, and Dr. Satyaban Ratna, Secretary IMS Pune Chapter, and distinguished delegates and participants of this symposium. Very good morning to all of you. And it is indeed a great pleasure to join this particular symposium. It is one of the unique things because it's a timely, and also I'm very happy to see that all the 4 institutions together organizing, especially 2 of the societies, Indian Meteorological Society Pune Chapter and Ocean Society of India Pune Chapter, together it is organizing along with the Indian Meteorological Department and Indian Institute of Tropical Meteorology. It is a very good initiative in this symposium, especially to understand the science of heat waves and the warming scenario and some of the challenges with this heat waves. As you all know that this heat wave, basically it is a what is called under the global warming scenario, the heat waves are become more frequent, intense and long lasting due to overall rise in average global temperature. Of course, it poses a serious risk to not only human health, but also agriculture, power sector and natural ecosystem and much more in that. So considering this forecasting heat waves or heat stress index, I can call it, is very important. and its relationship with not only local but also global warming. And it is very important for preparedness as well as how to make a mitigation strategy and adaptation strategy. All these things, it is very important. Our forecasting is very important tool. Of course, it is also we need to have a rising awareness about the impact of heat wave to many of the users, common man to different people, not only from the land side as well as the ocean side. So the interaction of heat waves and forecasting, the intersection, of course, the most of the heat waves as well as the forecasting and global warming is underscores the urgency of addressing climate change and implementing various strategic policy to minimize its impact on society in most of the environment. So our prime objective should be to improve the heat stress index. Of course, you can call as a comfort index, how to forecast this. Of course, it is not only simple temperature of maximum or minimum or whatever the things. Of course, we should develop a heat stress index, a function of not only temperature, but also humidity, wind, radiation, and also what is its frequency, duration, and intensity. All these things put together, we need to develop a heat stress index, and how we can forecast that. That is more important. Of course, you may have a superposition of waves. It is a decadal variability of heat stress index and interannual variability, seasonal variability, intra-seasonal and day-to-day index of all these things. We have to make a superposition apart from the climate trend. Overall, the climate trend we need to develop. So it is imperative to develop the heat stress index. Actually, it has to be very important because we know what we have done in the last year, where we have failed, where we have success, we should understand. And wherever you have failed, how to correct it, we need to make a plan for this. Of course, we have various models of a numerical physics-based model, but also we need, since we have a lot of data for long years, and I think we need to develop a fusion of both the physics-based numerical model and also data-driven AML. We need to fuse them. That is the way, because physics-based model will provide some good things, but certain things we fail to understand the physics. So we have to fill the gap of that through data-driven by AML. Of course, there are many other things, urban heat island effect and location-specific. All these things we need to well in advance. At least we need to forecast. That is our most imperative. Apart from land, of course, the marine heat wave also very important, because nowadays more and more marine heat wave is happening in the ocean, especially in the Bay of Bengal, and it impacts fisheries and also ecosystem health, especially coral and other things. So we need to forecast well in advance about the marine heat wave, and also because of the marine heat wave, whether the intensity of the cyclone or maybe the monsoon modulation or the extreme rainfall over the land, is there any change? All these things we need to understand very well in this particular aspect. Of course, we need to identify, is there any other observational tools or many other observational requirements is there required for heat stress index we need to identify. I think we need to incorporate, or we need to collaborate with many people, not only the research institution, but also academia and also various society like SAMA, IMS and OSI. All these societies we need to involve apart from industries. I think we need to involve all the people and also international partners we need to make. I think I will be very happy if all societies and academia and institutions together to submit some proposal to look at this specific aspect of how do we forecast, what are the different elements are there, how we need to forecast at different time scales. If we are able to bring out, it will be very good. As you all know that we are planning to have a next 5 years very major mission we are bringing out after deep ocean mission. So we are already carving out another mission. It is basically atmospheric mission or mission MoES. We are planning to have, under that we are planning to have a big way, not only observation, but also understanding and also modeling aspect of various components of the meteorological things. I think I look forward to your suggestions and feedback for this mission MoES. What are the components we need to build apart from HPC or whatever is required. So with this, maybe I wish the symposium a great success and fruitful interactions. And I'm hoping for what are the important findings in this symposium, and also I'm looking forward the fruitful recommendation and the way forward, maybe the roadmap for heat action plan. With this, I thank you one and all. And once again, IMS, all these IMS as well as IMD, IITM and Ocean Society of India, thank you very much for organizing such a symposium. And maybe similar thing you can plan for much other field, maybe the lightning or extreme rainfall and other things you can plan in the coming months and other things. Thank you one and all. Thank you.
A great thanks to you, sir, for your enlightening remarks and motivating us for working together to cope up with the warming environment. Now, there is one important announcement from IMS. For this, I would request Dr. Kumar Kolli, sir, to please.
Good morning. This is about an important activity of the IMS. In order to encourage young scientists, life members of the IMS not exceeding 45 years of age, as on the year of the award, having made significant contributions in research and operational meteorology or its allied fields of science and technology, are considered for the award of IMS Associate Fellowship. Based on the nominations made for the year 2023 and recommendations made by an eminent panel of the IMS Fellows, the following two young scientists have been elected by the IMS General Body in a meeting held last November on the occasion of the TropMet to the IMS Associate Fellowship for the year 2023. On behalf of the National Council of the IMS, I'm happy to convey our warm congratulations to the recipients and hope they will inspire and mobilize the participation of the younger generation more vigorously in IMS programs and activities. I request Dr. ABM Ajit Tyagi to kindly confer on the young scientists that I will name the IMS Associate Fellowship and a citation. First, Dr. T.P. Sabin, scientist, IITM Pune. Next, Dr. Gaurav R. Govardhan, scientist currently at IITM Pune. Thank you and congratulations once again.
It was our pleasure that these dignitaries joined the event and bestowed us by being our guest. So now I invite Dr. Satyaban Bishoy-Ratna, Secretary IMSP, to please come forward and propose the vote of thanks.
Thank you, Dr. Rasa. Good morning, ladies and gentlemen. On behalf of Indian Meteorological Society Pune chapter, as a secretary, IMSP, I would like to extend a warm welcome to each and every one of you. Today, we gather here for IMSP's National Symposium on Heat Waves. It is truly an honor to have such a wonderful gathering here. At the very outset, I would like to thank Secretary M. Ravichandran sir for kindly agreeing to join the symposium online. Although he was very busy after his returning from the abroad, he kindly agreed to join this important symposium. I thank Professor Shekhar Mande sir for kindly agreeing to be here with us as a guest of honor, and his remarks on the heat wave challenges is truly inspiring to all the participants here. I also thank Dr. Tyagi sir for his remarks and continuous encouragement for the IMSP related, the climate related challenges everywhere. I also thank Dr. Rupa Kumar sir for his experience related to WMO heat wave activities that need to be translated to the benefit of society. I also request Dr. Krishnan sir, Director IITM, for all the facilities provided here to conduct this workshop. And I thank our chairman IMSP, Sri Hosalikar sir. Unfortunately, he could not present here due to his injury. He planned his program very nicely, but we are really missing you here, sir. Thank you. And I also thank all the organizations, those who have supported here to organize this symposium, especially the Ministry of Air Science, India Meteorological Department, Indian Institute of Tropical Meteorology, and the Ocean Society of India. And I would like to thank all our sponsors, Sir Vaisala, SGS, Agista, Astra, and Microstep. We also like to thank all the invited speakers, participants, and students who came from different parts of the country to discuss various challenges related to heat waves. And without a thank, I cannot complete my vote of thanks. I thank all the volunteers for IMSP, those who have really worked hard for during the last 1 month to make this program a great success. Thank you all the volunteers of IMSP. Lastly, I would like to take a moment of express our sincere gratitude to everyone who has contributed to making this event a great success. Thank you very much. Thank you and all.
Thank you so much, sir. So now there is now we will have a group photograph of all the dignitaries and the participants present here outside this auditorium. Meanwhile, you all are requested to please copy your presentation in the system for the next sessions. And as we are getting little delayed and we are having a very tight schedule, so I request to all, please, it will be good if you will join here by 11 a.m. Thank you. Good afternoon. Sorry. Once again, good morning to all of you. Now we are going to start our first session of this today's National Symposium, where we are having invited talks as well as oral presentations. So to chair this session, and I would like to invite AVM Dr. Ajit Tyagi sir, and to co-chair this session, I invite Dr. Rajiv Chattopadhyay from IMD Pune. So over to you, sir. हाँ मैं बोलते बोला मैंने
Mike, please. Yes.
Yeah. Good morning and welcome to the first technical session. We get on to the business with the 3 plenary talks by eminent scientists who are working on ground in the field of heat waves, and followed by 2 presentations, contributing presentation. We have to manage time because it's a full day, very packed symposium. So may I request that for 15 minutes, after 15 minutes, you'll get bell warning and try to finish by 18th or 19th minute. So to start with, we have I think giving the settings for the entire day is Dr. Bhan Sahib, who will talk about the heat wave climatology trends, impacts, and management system. So give an overview of all things related to the heat waves. He is a director, DDGM, ADGM from IMD.
Thank you, sir. Thank you very much. And good morning, all esteemed delegates, chair and co-chair of the session. Thank you. So after a really very informative inaugural session where many of the issues were flagged by various eminent people, including how heat waves and high temperatures are becoming a threat to entire human society, various socio-economic sectors, and what is the need for monitoring and predictions and how complex the system is. My name is S.C. Bhan. I belong to the India Meteorological Department. So, as rightly pointed out by the chairman, to set the context for the deliberations during the rest of the seasons. So, what are these issues, the climatology trends and management system? And I will also try to point out to some of the issues which still need to be discussed in this. So for discussing anything, first and foremost, we need a definition of that. We need to define any phenomenon, any particular, if you want to deeply study it. And fortunately or unfortunately, there is no fixed definition of heat wave across the globe. UKMET office says the extended period of hot weather. The World Meteorological Organization says it's warmer than usual temperature for 5 days or more. Bureau says about unusually high temperatures. But it's really the impact on human beings and heat discomfort which matters. And this is a combination of many things, not just the meteorological factors, which includes temperature, wind, radiation, humidity, of course, sociocultural factors, and also the physiological factors also have an impact on our health. So they also need to be considered. And we in India have a definition of heat wave, which is a bit more rigorous than many other countries have. So we have definite thresholds for defining heat waves. which is the deviation from normal. If it deviates by a certain degree Celsius, we call it heat wave or severe heat wave, or based on absolute temperatures, it exceeds 45 degrees Celsius, that also is termed for heat wave. And then there are thresholds. In the plains, we don't call it heat wave unless the temperatures reach 40 degrees Celsius, despite any departures. And that limit is 37 for coastal areas and 30 degrees Celsius for the hills. So we have a definite definition of heat wave. This also has got some drawbacks that we'll discuss in the course of time. And what is the most likely period, most favorable period of heat wave is, of course, the summer season. Yeah. So this from March to June is the period. After June, the monsoon sets in and temperatures go down. But this window is not fixed. This oscillates. In years of late monsoon, this window extends up to maybe first fortnight or up 20th of June. And nowadays, unfortunately, what is happening, this window is more frequently shifting in the earlier part of the season, March and February sometimes. So that's causing a problem. Early onset of heat is the biggest threat because people are not prepared. We have not started preparing ourselves. So that phenomena is becoming more common nowadays. And these are the temperatures. May is the warmest month on many parts of the country. So the largest area or high temperature is in May. Heat waves are also in May. June, the area shrinks down. But certain parts of the country, particularly the northwestern and central parts of the country, they still remain quite hot during first half of June or so. If you see, this is 3 decades of June. So first decade is quite warm over many parts of the country except southern peninsula. Second decade also for northwest India, it is quite warm. And in case of delayed monsoon, even the eastern parts can remain. This is a case of delayed monsoon of 2005, where monsoon got stuck for more than 10 days over eastern parts of the country. And these red and brown areas show it's a very severe heat wave of 2005. So those areas suffered heat wave. So monsoon also modulates the duration of heat wave in the country. These are the historical temperatures. Most parts of the country in that zone have experienced temperatures of 47 degrees Celsius or so. So things get quite hot on many of the years. And how it is changing, coming to this is the scenario, coming to climate change. This is the research carried out very much here where we are standing in this institute. Dr. Krishnan, who was there in the inaugural session, that was the chief architect of this. And this shows 2-3 things. That the warming is not, the future warming and warming so far has not been uniform in the parts of the country. Number one, if you see the annual temperatures, the leftmost panel from top to below, it's the northern parts which have heated more in terms of minimum temperature, not that much in terms of maximum. In summers, which is March, April, and May, if you see the northern parts are impacted more compared to other parts of the country. And if you see the recent warming, will come to probably in the next slide. This warming has also accelerated in recent past. It's unevenly distributed, and temperature rise considerably above the global average or the Indian average have been realized if you see last 15-20 years or so. So this is a time series of warmest nights, which is nights having temperature above 90th percentile and warm days having maximum temperature above 90th percentile. These are the trend from 1950 to 2015, 65 years data. And this blue line shows the trend for the entire period, which in case of warm nights is 3.1 days per decade. And in warm days, it is 7.4. But if you see the red line, which is the recent trend of last 30 years, that is 1985 to 2015, night's rate of warming has increased more than double compared to the entire period. So very accelerated warming, and day temperatures warming has also increased in the recent past. And both of us should be a cause of worry. Warming nights are as bad as the warm days because the heat loads remain for most parts of the day. body is not able to shed the heat load. So adverse impacts get accumulated and they can be very dangerous on some occasions. And trends in that, those were temperature. If we see the trends in heat wave, the two are increasing. This is IMD report from 2021. So number of heat waves are increasing. This is averaged over more than 100 stations across central parts of the country. So these are the heat wave days. They are on a rise across the most parts of the country, but this data is only for central parts of the country. So their days are increasing, the spatial extent is increasing. This is a paper by Dr. Pai. The first panel on top is 1961 to 70 extent of heat waves, and the bottom right panel is the last decade of this century, 2000 to 2010. The area has increased during that decade. The intensity also has increased. So incidence is increasing, the area is increasing, the intensity is increasing. So all aspects of heat wave are increasing. And one more important part, if you see on the panel here, the top panel is March 2022, where there's a number of subdivisions on different dates experiencing heat waves. So up to 10 to 12 meteorological subdivision out of about 25 which are impacted by heat waves got heat wave in March itself. And the year before that, I not put the data, February was tremendously warm, 2021. It started around 16th or 17th of February, and till end it remained quite high. Temperature deviations as high as 12 degrees Celsius in northern parts of the country. Though it did not qualify to be called as a heat wave because of our criteria, but it proved really bad for some of the socioeconomic sectors. And this is April 2022. You see how many number of, on many days during the months we experienced heat wave. Last year it was June, I think Dr. Jaina presented it yesterday. And what does it impact? The most visible impact is on human casualties, because that's a very sad part of this. And the bottom panel here gives the number of deaths as compiled by the NDMA, the National Disaster Management Authority in the country. You see these two graphs after, if we remove 1995 and 98, those were outliers, high number of casualties. The total number of heats related deaths are on a rise all through this period. This is up to 2015. And it's here in 2015, I've stopped the data up to here. There are data after that also. The country put a heat wave management system in place. It's a very coordinating system, coordinated by the NDMA with IMD, the state governments, the health departments, and many knowledge institutes partner into that. But before that, something else happened in 2010. It's really important for the youngsters to know the history. In 2010, the Ahmedabad city experienced very severe heat wave. And on a particular day, I think more than 300 people died, where it's probably in some of the subsequent slides I'll be showing. So that brought the Indian Institute of Public Health, the Ahmedabad Municipal Corporation, and NRDC together to look into the causes, how it is related to temperature. And I'm happy two of those who were associated with this project are here, Dr. Mahavir Golecha and also Dr. Abhiyant Tiwari. They were closely associated with that project. Both of them are here. I think one of them will elaborate it a bit further. So, but before that, I just want to, so that you get it better. This is the graph. If you see these blue bars, these are average number of deaths per day during the month of May, average for 2008, 9, 11, and 12. Leaving 2010 outside, around 100, 110 number of deaths each day. And if you see the black bars, those are daily deaths in the month of May 2010. And these continuous lines, the bottom line is the average temperature of those 4 years daily, and the top red line is daily temperature for 2010 during different dates. All through the month, it was warm, and number of deaths each day is also higher. But somewhere here, when the temperature started rising, see the number of deaths. A city in which about 100, 110 people die on one day on 21st of May, 310 people died in the city. So that prompted this organization to look into it, and then they related it with the meteorological data. There was just one parameter, the maximum temperature of the city, and they found this kind of relationship. Up to about 40 degrees Celsius, there is not much change in number of deaths, people dying every day, though there is a variation, day-to-day variation. There is no trend. After that, they start rising. And after 43 degrees Celsius, there is a very significant rise. And number of daily deaths shoot up after 45 degrees Celsius tremendously. So that brought the Ahmedabad Municipal Corporation to impose the motility evidence-based thresholds of warnings. So temperature of 41, 43, and 45 degrees Celsius were delineated for different levels of warnings, and the India Meteorological Department then started providing warning to the corporation. The days even which did not qualify to be called as heat wave as per IMD criteria was also included in those warnings. And these warnings were provided to the municipal corporation, which further disseminated to other. And these were main components of heat wave. And this led to the first heat wave action plan of the country, not just country, probably South Asia itself. So 4 main components, I won't elaborate on them. I will leave it to Dr. Mahavir Golecha. I think he would do that. That involved an early warning system and interagency coordination, public awareness and community outreach, capacity building of the health professionals particularly, and reducing exposure to heat and promoting adaptive capacity of the general public. These are 4 probably all-inclusive aspects of heat wave. If we imply them, there can be more. Early warning system in this case is based on maximum temperature only. That may not be enough. Other parameters could be added, but that is one aspect it should be taken. So, and in 2015, if we see the previous graph, more than 2,000 people died in the country, and basing the experience on this experience of Ahmedabad city, the NDMA brought all the actors together and put the national heat wave management system in the country from 2016 onwards. That led to first national level guidelines of management of heat wave in the country, and led to a color coded warning system agreed upon by all by IMD. So after that, IMD have made it more, streamlined, though the system was there. So we provide the heat weather outlook at different temporal scales. Starting from seasonal outlook, we provide twice in the season, end of February for March, April, May, end of March for April to June, and for next month for every month. Then there is a extended range forecast system where we provide weather temperature anomalies for next 4 weeks and a daily forecast system. I'll finish in next 3-4 minutes. And what did it lead to? These are the deaths. After 2015, the number of people dying due to heat waves is continuously going down. So this is one of the success story of managing disaster in the country by coordinated science evidence-based implementation of an action plans. And if you see the number of districts impacted on the bottom left panel, number of districts impacted by heat wave are going on, but the average number of people dying per district is very less. So some of the other impacts, if we want to see, there are other health-related impacts in addition to mortality only. Heat-related illness manifest in many forms. So those are there. Impacts on agriculture, drought, poultry, maybe animal husbandry. Those are agriculture sectors impacted. Loss of livelihood of the people who cannot go to work because of hot weather or who fall sick because of hot weather. That's a serious concern. Energy demand increases during summers. Transport and tourism are impacted. Water demand goes up. And there are many other sectors. And this is one of the survey of the Ministry of Health, National Program on Climate Change and Human Health of NCDC. These are the heat-related, in the middle column, if you see, total emergency OPDs due to any region during different months of 2022, I suppose. If you see the May being the warmest month, reported highest number of OPD visits and also highest number of heat stroke related cases being admitted to the hospitals. So that's the impact. Other impact This is study carried out here in Maharashtra, Marathwada region of Maharashtra. But people report because of hot weather. Some of the symptoms reported by the people are headache, sweating, fatigue, and all these kind of things. And the odds ratio of falling sick or dying because of heat wave is tremendously high in those working outdoors, in the farms, Manrega, and other laborers working outdoors. The non-income generating activities are the people like us. They have categorized those working indoors. Compared to them, people are as much as 3 times more vulnerable to falling sick in that report. And then people imply different coping strategies for that purpose. If you see, the most common strategy is drinking more water, and less adopted are the red ones that include seeking shade, maybe staying indoor, wear protective clothes, change of the work. And the least adopted were use of sun coat and take a bath. And probably water is a shortage during summer or those areas. Sun coat has got economic implications. All cannot perhaps adopt. This is a good indicator. And though we don't have data of this kind in our country, these are trends in heat stress illnesses in average over 10 cantonments of the United States over 20 years period or so. Number of ambulance calls, hospitalization, and reportable events have increased tremendously. And there are economic implications of heat waves. The top panel shows the global equivalent of full-time job lost in 1995, and the red bars are the projection for 2030. Significant number of jobs are being lost, and they are projected to increase tremendously. This is a report from the International Labour Organization. And countries by 2030 would lose as much as 4% of their GDP due to heat wave. And coming to next impact on agriculture, the top panel, if you see here, is year-to-year productivity of wheat in Punjab. In Punjab, wheat is 100% irrigated crop, water is not a stress. If you see 2021, there was sharp dip in the yield of the wheat crop in Punjab. And on the bottom left side, if you see, these are the heat wave during February 21 was very warm. And February coincides with a very critical stage of wheat crop when the grain filling starts and hot weather reduces the crop growth season, brings down the 22 March was warm, so therefore impact was relatively less, but still it could not recover fully. Then quickly some of the issues we need to highlight here. Temperature thresholds, because as I discussed in the first slides, the IMD provides absolute temperature or temperature deviation based warnings. It needs to be impact based. So need to come out with thresholds of maximum temperature, maybe thresholds of various heat related indices also. That needs to be computed based on the impact so that effective warnings can be provided. The next is we need to engage the stakeholders. Unless we engage the stakeholders who are going to be impacted, we need to make them more aware. We need to tell where the forecast would be coming from, how to interpret those forecasts, and how to spread the messages across the community. That is important. That needs to be done. And the information needs to be tailored for specific users. Forecast information tailored for one group of people or one kind of socioeconomic activities would be different from the others. So that needs to be done. And some of the forecasts may be needed by one set of the people, some for other set of the people. Sir, another half a minute, please. We need to involve the local authorities because the actions have to be ensured by those. So municipalities have to be involved. And these warnings have to be co-produced at least, because we should co-produce with the health authorities, maybe municipalities. And then ownership would come and actions would be ensured on that. Warning dissemination has to be multi-stage, easy to understand, easy to act upon, and different modes of communication have to be deployed. This is one example. This is the last, sir. I like this. This is the old slide of February 2017 or so. This is not related to heat wave. It's related to thunderstorm. It's in Marathi. Many of you probably read it here. I can too read a bit. There was a warning of hailstorm in Marathwada from 10th to 13th of February, and it's beautifully warned. This, I think, it's secure your produce. And this is, if something is lying in the market yards, cover it. Third is take shelter in case of thunderstorm or lightning. don't stand under a tree, take your produce to the market. And some of the districts were particularly warned. Those are districts in Vidarbha. So that kind of message has to go well in time. This is the part youngsters probably can work. Many of you can work on each aspect of this. We need to know the risk. So are the hazard and vulnerabilities well known? We probably know the hazard. Vulnerability, I'm not sure. So we need to know that what are the patterns and trends in hazard. Hazard trend, we know at least one part of hazard, that's temperature. But how the hazard of heat index is increasing, decreasing, we don't know. Vulnerability still probably we don't know. Risks, whether they've been mapped or not, I'm not sure. Other warning, are the right parameters being monitored? Perhaps partly. So we are just monitoring temperature only. In totality, it is not being. Response capability need to be increased and dissemination communication has to be done. That's all. Thank you, Chair. Sir. Thank you. And apologies for a couple of minutes overshooting.
Thank you, Dr. Bhan. Well, you have rightly brought out in your last slide the needs to be done. A lot has been done. We have been able to bring down the mortality, but we can't be complacent. You see, you have not shown what happened last year. The number of deaths have gone up again.
Yes, sir.
So that is a lesson to be learned, that yes, we have got system, but this has to be operational around the year. And as we do the pre-cyclone warning exercises to make awareness, people brought into. So this has to be an annual exercise prior to the heat waves, during the heat waves, and after the heat waves, what were the shortcomings to analyze. And these are the areas which we need to go to the next level. So we have been able to do a good work as far as all-cause mortality is concerned, but a lot needs to be done, and I'm sure all young researchers here will address many of these issues which are there, very much required. Thank you.
Thank you, sir. Thank you very much.
For want of time, please you can discuss with him. He's available during the tea break, lunch break, otherwise also through the email. Thank you.
Thank you, sir.
Well, we have now next presentation from Rajashree. She is academician working closely with the planning department, though the majority of the culprit in the urban issues are the urban planners. And anyway, she is one which is trying to address this issue of how do we manage urban heat waves, urban heat islands. So very important presentation. She is, I think, one of the key practitioner in this field. Thank you, Rajashree.
Thank you. Thank you so much. A very good morning to all of you. I'm happy to come back to IITM. I'm going to talk about certain things. I'm going to talk about certain.
Rajashree, request to keep the time.
Yes, yes.
Okay.
So I'm going to talk about certain things which are linked with heat action plan. And since I'm an urban planner, my focus will be essentially with respect to the cities. As is already known, there are multiple impacts that heat waves have. And if you look at the settlement-wise, it's rural against urban. My focus is urban. But in urban also, there are multiple aspects that we talk about. Why urban? Because so many people stay there. They are the engines of economy. There is a lot of urbanization. That the pace of urbanization is very high. So it's very difficult to respond. And it is also a part of a problem and a solution that we are discussing today. So we are kind of culprits as well as we can become a part of a solution. And most importantly, most of the science in the domain of cities, that is urban science, is not available in a form which can be translated for implementation. And that's why a major concern should be there for cities. What I'm going to present partly is the heat action plan, give you a peek into that. what kind of science or studies we did to able to come at the heat action plan. What kind of mitigation measures can we talk about at the city level, and partly talk more about problems than solutions. We all know that this has been the progress in heat management as far as the cities are concerned. I'm focusing on just cities. Uh, and this is how the India developed. Into 2019, it was the first time that a chapter on built environment was added to the heat action plan, and where it was acknowledged that built environment is a part of a problem as well as it can be a part of a solution. What we are coming up now with, that we have prepared this handbook for the preparation of a model heat action plan. I know it sounds a little, I mean, there can't be a model heat action or framework for a model heat action plan for a country as complex as India, where the urban itself can be defined in so many ways. And there is a variation in climate and cultural aspects. But as I said, it's a framework which needs to be changed, modified as per the local conditions. So it becomes a guidance for the people who wish to prepare a heat action plan at the city level. Some principles that WMO, WHO guidelines give us while preparing the heat action plan. These principles have been followed while framing the model heat action plan. Essentially, the most essential part is whatever existing policies are there, because adding another plan is not a good idea when we are talking about people who are implementing. They hardly have time. They have a lot of things on their plate. So if you add another policy or plan to their plate, they are not going to agree. So the job of a scientist is to take the science in such a way that it integrates with existing planning plans or policies, or maybe add something to the existing policies. Then adopt a long-term approach. It's very important, because all that we have been doing is a crisis-oriented approach. It has to be multi-sectoral. It can't be just focus on one particular sector. So be broad, multidisciplinary, multi-sectoral. Communicate effectively, which is known to all of us. And most importantly, ensure that the efforts that you make to reduce the impact of heat waves does not lead to an increase in the or any burden to climate change issues that are already existing. And most importantly, but which is not being done till date, is evaluate what you have been doing. Some of the concerns that we have, as has already been discussed, is we are crisis oriented. We still only focus on mortality. We don't still understand the scale and complexity of the city. So a heat action plan for Delhi against a heat action plan for Solapur would be very different. They will have to be designed differently. That complexity and scale is not being addressed as yet. We don't have a proper definition, in the sense, as has already been talked about, local threshold based definition will be a key. There is no standardization as to how do you map the vulnerability. It is not important to just identify, because identifying the population group which is vulnerable is very easy, because that is known. Public health already tells me that. But identifying spatially where these people live, or maybe what are the areas in the city which have a high exposure, and due to high exposure they have a high vulnerability, which might get converted into high risk, is something that is critical. Which is, so there is no standardized method of mapping the vulnerability. No periodic monitoring or evaluation. We suggested something. QHI, which is research proves that it kind of increases the problems of heat wave, is not being taken, is not being studied in most of the cities. Something which we need to do on the long term is talk about, integrate it with national policy, which is a big task. I don't know when we will be able to do. Most importantly, talk about water. Every time we talk about heat, we don't talk about water, because we always look at water independent of heat, and heat is being discussed separately. But today you look at Bangalore, the temperature is increasing. At the same time, there are water crises. Many cities might face the similar problem. And my limited knowledge of research in urban planning tells me the solutions for water can also become solutions for heat. Lack of trained and skilled manpower at the level where it is being implemented. So there is no point talking about a lot of science in silos and not being able to implement it on ground, because the agency that implements does not have the capacity to understand what we are talking about here. I mean, I'm just putting same simple facts. And lack of forecasting and modeling with respect to impacts at the city level. So we don't have a city level modeling or forecasting activity being done at urban level where it can understand what kind of impact it would have on different sectors, including economy, energy, or maybe health. So what does this do? It kind of prepares a framework. It tries to become a guideline for the ULBs, so something that can be used by a municipal corporation. It tries to be holistic, multi-sectoral, and it gives a lot of thumb rules which are based on science, and the person doesn't have to understand science, can just follow the rules that if the population density is so much, if this is so much, if this is so much, do this. If this ward has this, do this. That kind of approach. And but overall, MHAP has multiple objectives. One of the objectives to reduce mortality and morbidity, but the most important is to improve the microclimate, because in the long run, if you improve that, it will automatically have an impact on morbidity. Improving, reducing the morbidity and mortality. Something that we have not been able to address is integrate water and heat. And lastly, work towards the heat resilient cities. That should be the ultimate objective. So it tries to have three different temporal scales: short term, medium term, and long term. Currently, most of the Indian cities are in the first temporal scale, that's short term. How to reduce mortality and how to reduce only mortality, not even morbidity. And we are happy about that. But we are trying to say that, can you take it ahead? So what to do, where to do, when to do, and how to do is something that it tries to tell. So just to give you a peek into what it looks like. So the short term essentially has the multiple components. One is effective heat health warning system, effective communication plan. So it also gives you a guideline of how to rapidly assess, do the heat vulnerability. So there's just one single page for them, is which ward has this, which ward has that, which ward has this, and then finally it tells you the ward with this is has the highest heat vulnerability. Please focus on those things, something like that. So based on the studies that we have done, then it preparing the heat health infrastructure for the possible eventuality and how to improve the quick response. It gives you a timeline as to when to do, what to do. It also gives a small process-based evaluation form, because evaluation can be done in two ways: outcome-based and process. Outcome is going to be very difficult, so we converted to process-based evaluation. Then in the medium, we are focusing more on hyper-local. I'll talk about it a little more, and the other things also. In the long term, of course, there is a lot of role for meteorology department, where we want to forecast and model the cities essentially. Also public health and epidemiologists, what impact can it have on other health related issues. And in urban planning, of course, developing cooler cities. So I'm just going to run through some of the study that we have done to be able to arrive at this. So this is the science which supports whatever document I just discussed. So local threshold, as has been discussed, we all have been using mortality data for local threshold, which is not right, because that's the last time. I mean, you don't talk about mortality essentially when you talk about threshold. But unfortunately, we had to use a mortality data. So what we did was, we had mapped it against a lot of indices, WBGT, HD, HI, and all that. But finally, we realized that it's the temperature that is in the driving seat when it matters mortality here. So this is something that we observed. So it was the T minimum as well as T maximum. Both of them had a relationship with mortality. And then there was a point of inflection that we tried to find out in both of them, So in case of T max, it was 42, and in T minimum, it was 30 degrees Celsius. The other thing that I have talked about was, do you have a spatial, sorry, uh, do we have a spatial framework to map this? Because as an urban planner, I'm more interested in where is the problem, and how do you address, or what is the reason for that particular problem. So we kind of use a local climate zone classification. We classified the whole city. I will not talk about local climate zone classification. I think many of you must be aware of that. And what we observed, so initially, like the UHI was being discussed, so we tried to see that across the local climate zones, which are kind of, one single zone is based on the kind of morphology that it has, which has an impact on the temperature. So it is assumed that a certain local climate zone will have a similar temperature, temperature across the 24 hours. So it will behave in the same way. So what we observed was the places with the highest uh, vegetation were the coolest during the day, during the night, whereas the places which are high built up experience the high nocturnal stress. Whereas during the day, the sparse built up was the one which was experiencing during the day, it was the high built up which was experiencing the heat stress, whereas the one with high built up did not have a high heat stress during the day. Now, how does it get translated in with respect to local threshold also? I'll show you. So if you map it, I mean, it's a deviation from the mean. If you map it, this is how the city looks like during the day. This is how it looks like during the night. The ones in the red are the one in stress at night. So how does it behave? We also spoke about, we also took HI, that is heat index, and tried to see, if you take a typical summer day, how long does one particular LCZ stay in stress for what kind of duration of the 24 hours. So one can see that there is a lot of variation. So it's number 9 that stays in the higher zone of danger for a long duration, which is something which is sparse, that are the fringes of the city, also has a socio-economically vulnerable population living. So you can say it has a high vulnerability, high risk, because the hazard is also high. And this is the UHI, you can see here. So UHI intensities are extremely high in 9 during the day, when it is also experiencing the high, that is a zone of danger as far as HI is concerned. Now, these thresholds are taken from the US, this thing. They are not Indian thresholds. The local threshold that I showed you, then we translated that into LCZs. So if the minimum, so if we go by the heat wave definition that we have of maximum temperature, then only these, and we take that as a threshold, then only these LCZs are essentially experiencing temperature. The mean temperature is above 42 degrees Celsius. I'll finish in 5 minutes. And the one which does not experience any heat wave during the day has a highest nocturnal stress, and is the one which is highly populated, where 30 to 40% of the population in the city lives, which is experiencing a highest nocturnal heat stress. And imagine, nocturnal heat stress is the time when people are inside their houses. So that's really very, very critical. So it's the relevance of hyperlocal approach when it comes to heat action plans. This also tells us, this is also trying to discuss, when we are talking about reduction of indoor heat, how this was the base case of a house in a slum, and how we made modifications in that. And some of the modifications that we made were they became comfortable. So the idea is, how can we improve the indoor heat stress, most importantly in the vulnerable housing typology. So the most critical is the slum types. Can we make some modifications in that, and then how do you reduce the indoor heat stress in that? We also did the heat hazard mapping, heat vulnerability mapping, and based on that we calculated the heat risk. then calculated the parameters, found out the parameters that have a strong linkage with vulnerability, inserted that in the heat action plan to make the rapid risk assessment format. Then to go ahead, how can we build heat resilient cities? We also had a study done on urban form and the temperatures. What are the pointers in urban morphology that have a direct relationship? So you can see the FSI that we talk about is a combination of all these parameters that we had discussed, which play an important role and have an influence on temperature. So next time, if there is a development control rule, we can predict what kind of temperature, what kind of increase it would, decrease or increase it would have in temperature. These are some of the mitigation measures, what impact they have. Then we tried to see that in 3 different areas, if you take the same mitigation measures, do they work? So we realized that in some areas which are dense and do not have uneven height, it's the cool roof that works. Whereas if you have uneven heights and sparse areas, is the vegetation that works. Combination of uh, trees along the street and vegetation works. But in areas that are plotted, it's the trees along the road that works. It's important to have these studies so that they can help in the city vegetation plan. So the idea is not to talk about one particular low-hanging mitigation measure every time. It is important that you understand which particular mitigation measure works in what context of the morphology. So it's not necessary that cool roof will work every time. We have not yet touched the critical infrastructure, the impact that it has on water supply. Currently, we are studying that and how we can improve the resilience of the critical infrastructure. Some of the contributions of this work, I would say it's just the beginning. It tries to bring in other aspects other than the short term in terms of temporal scale. And other than the public health, it brings in a lot of other disciplines on board and tries to make it a multi-sectoral and broad approach towards heat action plan. And I'm not saying that this is the end of it. I would say it's just providing the first framework which is available for modification, changes, improvement, and based on this, we can have a better heat action plan in future, where it would lead to a heat resilient cities maybe. Thank you so much.
Okay, thank you. If so, well, she has shown the path which we have to embark upon for addressing the urban heat issue, which is very much required, seeing that we'll be urbanizing in a very fast pace in coming decades. And already the cities are facing acute heat stress. So thank you, Rajashree. And now we go to the threshold, which has been talked about, because ultimately for each sector and each impact-based warning can take place only if we have thresholds available. A lot of work is going on based on percentile, based on the health data, and various other indices which are there. Secretary also brought out that the stress comfort index is to be tested. So with this, Abhiyant has been working initially within the country, but now is a global player. So he can bring a lot of international scenarios which can be implemented in India also. So Abhiyant, for you, and another 15 minutes.
I hope I'm audible. Great. Very good morning. We actually, Bhan sir and Rajashree ma'am made my job a bit easier, and also secretary in the inaugural session. we talked about threshold. I mean, threshold is something that came up again and again into the discussion by various speakers. So I'll be talking about the health-based thresholds for heat early warning systems and why it is important. Need not to get into the details. Temperatures are rising at a much faster pace that we expected. And like in 2015, Paris, you were talking about that, we should try to restrict the global warming by 1.5 degrees Celsius by end of this century, but doesn't seems to be happening, right? We are almost breaking the records by every passing year. So yeah, and heat-related mortalities for vulnerable population, particularly if I talk about this study from Lancet, there has been an increase of 68% recorded between the period of 2000 and 2004, and in 2017 to 21 as compared to 2000 and 2004, particularly in the vulnerable communities like people with more than 65 years of age. And again, from Lancet itself, the heat is going to cost more than, have burden of more than 370% deaths because of heat that is going to happen by mid of this century. And where would that happen? Mostly in the region where we are living, in the Southeast and South Asia region. So yeah, it is a big matter of concern. Is there anything wrong with this? If anyone can talk about. I promise to finish my talk in 20 minutes, but if anyone can, highlight about like what's wrong with this person, or what's wrong with this, quote. The heat wave is making me as unproductive as any typical work day. So either there is a heat wave on all work days, or there is something wrong in the heat wave forecasting. Either you cannot be unproductive on all work days, or all the work days when you are forecasting your heat wave, there is something wrong with that, right? So what is wrong with that? So in this session, we are going to talk about the importance of temperature thresholds in the heat health early warning systems. What are the best available options for estimating the thresholds, and what are the decision maker dilemmas? We do a lot of research. We are science community. We do a lot of research, but when you sit on the other side, from the policymaker side, you will realize the dilemma. You will realize the challenges, the real challenges to implement science on the ground, which is very essential, and we should think about that. We as a science community should think about that. Like, how can we make our science more easier, more translatable for the policymakers? Cool. So what are heat health early warning system? They are basically a component of the heat action plan, which is a larger policy document. Heat health early warning systems are part of the larger policy document of heat action plan. And fortunately, among all other disasters, impact-based forecasting system for heat health early warning systems, Heatwave have advanced to a quite, advanced level, both in spatial and temporal scales compared to other disasters. Now, when we talk about what are the best options available for estimating thresholds for heat health early warning systems, let's take a step back and talk about what exactly is heat stress, right? We say a situation where too much of heat is absorbed by a person or a human body. How much heat is too much heat? Is that what we call heat wave? Sir explained about the definitions, Indian definitions of heat wave by the Indian Meteorology Department. So what is heat wave? In nutshell, it is a prolonged period of abnormally hot weather there is no universal definition of heat wave, or there is a no universal threshold for heat wave, and it's a very local phenomena, right? For example, the relationship between temperature and mortality varies between different geographies within India itself. This is a very recent study, 10 city study that we did, where we evaluated the impact of heat on health, where the threshold, I mean, the relation between temperature and mortality was varying between Delhi, Varanasi, Chennai. I mean, in different climatological zones, the relation between temperature and mortality could vary. So there cannot be a universal definition for heat wave. For example, in 2003, in Europe, where more than 70,000 people died in a heat wave, more than 17,000 people died in France itself, when the temperature was hardly hovering around 37 degree to 40 degrees Celsius, right? And our definition for heat wave starts after 40 degrees Celsius in the plains. जब तक 40 नहीं होगा तब तक तो हम प्लेन्स में हीट वेव कहेंगे ही नहीं, right? So that's something very important. So there is no universal definition. It's a spatial phenomena. It could be regional, sub-regional, local. It's a temporal phenomena also, like one day with 40 degree, more than 40 degrees Celsius temperature or 45 degrees Celsius temperature may not have impact on the health of the people. It could be 2 days or 3 days, but in some places it could be just 1 day. In Srinagar it could be just 1 day above 40 degrees Celsius or 45 degrees Celsius, which could affect the health of the people. So it's a spatial phenomena, it's a temporal phenomena, right? So for example, this is from 2022. We can clearly see that in Chandigarh, at 40 degrees Celsius, there was an alert for heat wave, right? In Kolkata, at 41 degrees Celsius, there was an alert for heat wave. But in Ahmedabad, Lucknow, Jaipur, Delhi, even at 42, 43 degrees Celsius, there wasn't an alert for heat wave. So it is not equal for all the places, right? So what is this like? Where should we alert people? There has to be a threshold, local threshold. And what could be that, right? It could be any thermal variable at which the risk of adverse health outcome increases substantially. What are the thermal variables available? We all are meteorology scientists, so we know Tmax, T minimum, T mean, heat index, which for India, which is not available as of now, perceived temperature, humidex, WBGT and UTCI, which are more complex phenomena. But globally, Tmax is the most widely used variable for heat health early warning systems in the heat action plans. And this has also been reported in the, recorded in the systematic reviews, global systematic reviews. So you can see that Tmax has been mostly used variable in most of the heat action plans. All right, so how do we do that? Like, which health impact outcome variable can be used for estimating the threshold? What should be the health impact outcome? It could be all-cause mortality, which is available, most widely available. Cause-specific daily mortality count data, hospital daily admission data, and emergency ambulance call data, which is also with the advancement in the emergency ambulance services is available now globally. Again, if I talk about globally, the all-cause mortality data is the most widely used one. Who can do this? Like, how to do this? Epidemiological studies. We can do the time series analysis. We need to be considerate about the confounders like air pollution, any outbreaks if happened during the period. Is there any acute or average effect? We need to adjust for the seasonality, and if there are any lag effects, so we need to understand that also. Who can do it? Any epidemiologist or biostatistician at district level or state level medical colleges, public health institutions like Indian Institute of Public Health. Any other domain expert who can do it. IMD has started doing it And this has also been recommended by the guidance from World Health Organization, WHO and WMO, in their guidance on uh, heat health action plans, heat health warning systems back in 2015. Then that in setups in countries where the mortality data or the impact data is not available or is not of good quality, you can still go by the percentile approaches. They recommended, I think, 95th and 99th percentile, but IMD has already started doing it at 90th percentile, 95th percentile, and 98th percentile. So if you go on IMD website, you will be able to find the information on temperature forecast and what are the cutoff values of 90th, 95th, and 98th percentile for the region. Who can do it? IMD, as I mentioned, has already started doing it. What's the most concerning thing here? Ahmedabad had, like, this is again from 2022. Ahmedabad had temperatures, I mean, maximum temperatures above 48, 47, 46 degrees Celsius forecasted. But what was more concerning here was the minimum temperature, right? So even the night temperatures were above 28 degrees Celsius. And in our own study of 31 year of data from 1987 to 2027 in Ahmedabad, we found that when we restrict our analysis of maximum temperature at 42 degrees Celsius, every 1 degree rise in the minimum temperature about 28 degrees Celsius was more, lethal on all-cause mortality as compared to every 1 degree rise in the maximum temperature. So night temperatures, as rightly mentioned by Bhan sir also and Dr. Rajashree also, are very important that we need to now start considering about. And thankfully, MD is already doing it. But as part of Ahmedabad Heat Action Plan, they have started providing the forecast for the night temperature also in their forecast to the city authorities. We also need to think about the vulnerabilities here. Who are at greater risk? Women, of course, in general. And when we talk about the night temperatures, when we talk about the night temperatures, when we talk about the indoor temperatures are very riskier phenomena that we need to work upon. But in general, women, I mean, female are at high risk compared to the men. And also people at the extremes of age, people living in the, for example, the central zone and the south zone. South zone, for example, has the highest, number of slum wards in the city. And people living in the central zone, which is most densely populated area in the Ahmedabad, are at the high risk of the mortality due to heat. Over a period, we have seen an adaptation phenomena coming up. At maximum temperature, the risk has literally gone down, but at minimum temperature, it has gone up. So what should be the statutory unit for estimating the threshold? Whether it should be done at a megacity level or city level or at a urban, agglomeration or at a district level or at a village level. Ambient temperature doesn't vary too much geographically within a district. They don't vary too much within a district if the district is of not of too much of a larger size. So threshold estimation should be done at a megacity level, like where the population is more than 1 million. And there should be operational units for heat action plant development and implementation. IMD, NRDC, IITH, Gandhinagar, and NDMA did this study for more than 103 cities in India and estimated the thresholds based on both. Wherever we had mortality data, we did the epidemiological study, and wherever we didn't have the mortality data, we used the percentile method to develop the thresholds for more than 103 cities in India. Last part, constraints in policy decision making, right? Which methodology to use? We talk about heat action plan, we talk about estimating the thresholds, but which methodology to use? Like, who will be implementing the heat action plan? Do we have a heat exchange? How many of you are from Pune? Okay. From Maharashtra? Okay. Do you know if your city or your district has an active heat action plan? Active. No hands? Only ma'am. I know ma'am. Okay. And what it is based on, like which is the variable that your heat action plan uses for the alert? Tmax? Tmax. So as an authority, like it would be either the municipal commissioner or the district collector or magistrate. In some cases, regional commissioner, or what they call divisional commissioner, has to take the decision. It's complex. What should be the variable? The science community should answer that, right? As I mentioned, Tmax globally is the most widely used variable. But yeah, as a decision maker, if I step back and I wish I could sit in a DM's chair, and then I had to make a decision like, what should I use? Should I ask the Indian Institutes of Public Health or VNIT, come up with a threshold which is based on Tmax? Do I have that authority? I mean, so that's the decision maker's dilemma. So we need to tell them like which should be the variable for that. Fortunately, there is also a concern about the accuracy of the forecast. Fortunately, IMD's forecast accuracy has improved over a period, particularly in the for heat wave forecasting, particularly in the day 2, 3, 4, and 5 over a period. Which impact data, again, just like mortality, which impact data to use if you want to do an epidemiological time series analysis? Should you use all-cause mortality, cause-specific mortality, ambulance call data, or which data? So those are kind of the questions that we should think about. So if the y-axis is all-cause mortality, where would you set your threshold? At temperature 1, temperature 2, or temperature 3? How many for temperature 1? Let's say temperature 1 is 35 degrees Celsius. How many for temperature 1? No one. Temperature 2, let's say it is 40 degrees Celsius. And temperature 3, if it is 45 degrees Celsius. Now I said it is all-cause mortality. What about if the y-axis also has heat-related morbidities, not just mortalities? Right? The burden on the health system starts way ahead before the mortality starts. When the person reaches to the hospital, the burden on the health system itself starts. So we need to think about that also, whether we need to be more conservative. Decision maker's dilemma again. We need to be more conservative, or we need to be more liberal. Okay, I can keep it at 15% increase in the risk of mortality. Yeah, but in all case, early warning systems are doing well. Countries with early warning systems have 8 times lesser mortality rate as compared to the due to disasters as compared to the countries that do not have early warning systems. And we need to all work together and must act now to manage the unavoidable, which we call adaptation, and avoid the unmanageable, which we call mitigation, right? Before it is too late. So we need to communicate better for a better change. That's all from my end. Thank you so much.
Well, thank you, Abhiyant, bringing out mortality related to health part and including the morbidity in that. So yes, but the question lies with the health data. If you go to any of the developer, he'll say there is no health data available. Earlier, people used to complain about there is no meteorological data, but now that issue is settled, that you ask for any meteorological data, it is available online, or otherwise also the IMD is very open, and even the research institutions are open to help you out But as far as health data is concerned, it's a real challenge. It is being addressed now. There are some framework which are coming up. So in the future, even the health data will be equally available in the way which require. But till then, yes, we have to work whatever is available. Thresholds are being worked out. Success lies that how to implement them by the people on the ground. And the cities which are doing it, I think they have been able to bring out. But the cities which don't do it, we are in problem. So thank you so much, all the three eminent speakers bringing out, giving a total picture about the heat waves and its management. Now we have got two contributory presentations of 10 minutes duration. Rajiv, you will.
So first presentation is by Raju Mandal from IITM. So it's a 10-minute presentation, 7 minutes you'll be given the bell, and then please.
Good afternoon, everyone. Am I audible?
Yes.
Okay, thank you, sir. So I'm going to present some results, initial results on the heat wave patterns over Indian region and their associations and the particularly subseasonal prediction skills in predicting the heat waves. So as we know, the heat wave events phenomena is very complex, and primarily it linked to the anticyclonic circulations in the middle to upper to middle troposphere, that is sometimes we call the blocking highs, and which extend into the lower troposphere and leading to the strong subsidence, clear sky conditions, adiabatic heating, and increasing the sort of solar radiations and leading to the heat wave-like conditions. There are other factors also that modulate heat waves. For example, the minimum temperature, like nighttime temperature, high minimum temperature, and the humidity factors. And there are many studies that they have projected the heat waves. For example, the Misratal 2017. So they have demonstrated that severe heat wave days may increase by 30 times under the increase of global mean temperature by the end of 21st century. So it is very much important to understand the heat wave events, their patterns, associations, in particular the real-time predictions across the different scales. So this analysis, the following analysis, I'll be showing on the patterns of heat waves over the Indian region, their associations, and particularly the subseasonal prediction scale that we of the extended prediction system of IITM. So to do those analysis, I have used the high resolutions daily maximum temperature from IMD, right from 1951 to 2023. And for the composite analysis, I have taken the NSAFE reanalysis data sets. And from model, the model datasets have been derived from the multi-physics, multi-ensemble prediction system, the second generation of our extended range prediction system. And these models runs are carried out from 2003 to 2018 as HINCAST. And we have 6 physics configurations, and each physics has the 3 ensembles. So total we have 18 members to generate the probabilistic forecast. And last year onwards, we have implemented the criteria in the recent version of this forecasting model for the real-time heat wave forecast. So forecast data sets we have for 2023 only. So this is the methodology. We have taken this criteria from Mandala to 2019. So a heat wave day has been defined following this criteria when the maximum temperature of the particular day is greater than 36 degrees centigrade. Also, the climatological line, it is greater than or equals to climatological 95th percentile value, which is derived during the summer season and over the period 1980 to 2010. And also the deviation from normal is greater than 3.5 degrees centigrade, that is basically anomaly. Or simply when the temperature of that particular day is greater than 44 degrees centigrade, then that day will be called as heat wave day. And in that paper, we have also identified 2 heat wave prone regions, that is northwest and southeast. So over these 2 regions, we have identified the heat wave spells following the taking the area average Tmax data sets and setting the 2 thresholds. These thresholds are set depending on the 95th percentile values. So we have used the model data sets after correcting the climatological bias, daily bias, following this equation. It's a very simple bias correction method. And to analyze the skill of the model in predicting heat waves, we have considered the symmetric extremal dependent index. So this index has been used for a rare binary event, but we have used this index for probability forecast after fixing the probability threshold. So these results shows the decadal variation of the heatwave days. This is the heatwave days anomaly, total heatwave days during the season anomalies from 1951 to 2027 decades. So clearly we can see there is a significant change of the occurrence of the heatwave days, total heatwave days over the last 3 decades, and particularly most significant over the recent decades, 2011 to 2020. So you can see over the northwest, central, and the parts of southern regions, the number of heat wave days are occurring more in recent times. We have also analyzed the month-wise decade average heat wave days. So there also we have noticed that outside the peak summer months, for example, over during the March also, the parts of southern Indian region experiencing a significant number of heat wave days, even in the month of March. The corresponding significant trends also calculated for entire period 51 to 2022. So we can see over this region and over that region that there is a significant trend of heat wave days, total heat wave days per year. And there are some regions over northeast and this part. So there is a decreasing trend of heat waves. So this figure shows the total heat wave days per year. These days are calculated from the identified spells. So this is the total year-wise total heat wave days over the northwest and southeast region. So we can clearly see, and the black line shows the 11 years running mean, and dotted red line is the linear trend, and this is the corresponding p-value. So the p-values are significant for the both regions. So from these two regions, we can see the number of heat wave days in recent times is increasing, and over the southeast coastal regions, the number of heat waves is significantly increased in the last 10 years. And this is also corresponding to the heat wave days corresponding to the longer heat wave spells and the shorter heat wave spells. So over both the regions, we can see clearly the heat wave durations are increasing. There is a significant trend for the longer duration heat wave spells, but this is not significant for the shorter events. And this is the composite analysis for different regions. This is for northwest spell. So this is the geopotential height anomalies over 2000 hectopascal level, and this is a vertical velocity omega. Positive means a subsidence, and this is SST anomalies, and this is a surface winds at 925 hectopascal level. So from this figure, we can see during these type of heat wave spells over these regions, there is a anticyclonic pattern. This is blocking high, and the corresponding subsidence also we can see over these regions. That may lead to these clear sky conditions and hitting to the surface and leading to the heat wave-like conditions. And from these regions, we can see there is a strong northwesterly winds, and that may bring the hot and warm air from the arid region. And there is a paper in Navin et al. They have shown that there is a strong correlation between the Indian Ocean SSTs, positive SSTs, and the Tmax over the surface in this. So we have analyzed for the southeast regions also. There we can see the shifting of this blocking and other parameters. So there is a distinct differences between these parameters over for the different type of spells. So we can see there is a divergent wind out from the Indian region. So that may reduce the sea breeze and leading to the heat wave-like condition over these regions. I forgot to mention we have considered another type of spells that has the at least 1 day overlapping period for that two regions. So that we call the northwest and southeast to see the distinct patterns whether there is different association between the heat waves and large scale parameters. So there also we can see the strong SST anomalies persist over these regions, and over entire region there is a blocking high, and there is a quasi-stationary Rosberg patterns also, and over these regions there is a strong subsidence. So that may lead to the heat waves formation over there and propagating through this region. So this is the skill of the extended range prediction system of IITM. This is the latest version we are running experimentally, and this is the existing version run by IMD. So there we can see there is a significant improvement up to 70% probability threshold with this recent version, particularly in week 2, week 3, and even over some regions in week 4 also, there is a huge improvement in prediction of the heat waves. So this is the verification of our real-time forecast. As we can remember, the last year in mid-June, there was a intense heat wave spells over the Bihar and East Uttar Pradesh and this coastal Andhra Pradesh region. So this verification plot is from 2 to 8 June 2023, and this is for the next week. So we can see the heat wave setup over these regions during the first week of June. This is observation, and subsequent 4 panels are for the model predicted values. This is a probability of heat waves using our criteria. This is also observed. So in the next week, we can see over the vast region, there is a very intense heat wave-like conditions, and model could predict this spell up to 4-week leads, though there are some special errors in longer leads, but overall, the model could predict very well over this years. And at the same time, there was a cyclone also, but still these regions experienced a very intense heat wave spells, and more than 100 people died that time. So this is a showcase that our model could predict these events up to 4 weeks lead time. So summary already I have discussed. Thank you.
Thank you. So new version of ERP is having better skill. That's good to know. So any question? One quick. Yeah.
And I had conversation with him also. This will be wonderful actually for this season also.
Now. Thank you. So thank you. Next presentation is by Dr. Arulalan.
Bharat.
Good afternoon, everyone. So I would like to present this is one of the PhD chapter, atmospheric blocking over North Atlantic teleconnect, the heat waves over the northwest India, a study of present and plus 1.5 degree and 2 degree warmer world. So the top panel shows that era of geopotential height at 500 hectopascal anomalies. It shows that this is composite event, which is Tmax over the northwest India, preceded by the North Atlantic region, which is marked over this region. It is a very high geopotential height, high anomaly at 500 hectopascal. And it shows that a very high anomaly over this region, North Atlantic, as well as over the India. And this shows that Northwest India Tmax anomaly for the same composite period. This is from 1979 to 2018 during the March, April, May, June, that 4 months. Here it shows that Northwest India Tmax anomaly, which also like very high. You can see more than 3.5 degrees Celsius. And this figure shows that a correlation between this geopotential height at 500 hectopascal over North Atlantic versus this Tmax over the Northwest India. This correlation also shows very high, like more than 0.6. And here it shows like a time series from 1979 to 2018. The bottom panel shows that Northwest India Tmax. The trend shows like a 3.7 days per decade. And whereas this middle panel shows that era of 5 geopotential height at 500 hectopascal over the North Atlantic region. That also increasing trend like 1.7 days per decade. Whereas the top panel shows that it is Northwest India Tmax events preceded by this North Atlantic era of 5 at 500 hectopascal. That also shows like it is increasing trend like 0.8 days per decade. And this is the granular causality results shows that from the same period like 1979 to 2018 during March to June. It shows that we made the causality statistical test. It shows that we made the hypothesis that geopotential height does not grant cause the Tmax, like it's not Atlantic, not affecting the Tmax over the India. This is a hypothesis, and that is being rejected at 0.05 significant level for the lag of 3 days. And now we are discussing about the Rossby waves. Rossby waves, like this is the one of the Rossby wave number during the same composite event. Era of Tmax over the northern hemisphere has been displayed here. Like in Rossby wave 9 and Rossby wave 7, or like just this is Rossby wave 8. These numbers are just to depict how the Rossby waves and then modulate the high over the height over the North Atlantic, and then it's causing the high temperature over the Indian region. And here I displayed the mortality versus here versus the Rossby waves during the March to June. Like we have seen that even 2015, like a single Rossby wave was there, like Rossby wave number was 9, but luckily NDMA and SDMA made it reduce to a single double digit for the mortality in the recent years. So here we are discussing about the event coincident analysis. This also enters the statistical method. That will it is similar to the greater causality, but it also tells how much the two events are coincident in terms of 0 to 1. The more than 0.5 is very good correlation, like a coincident event. So this is a 5-dimensional figure, 5-dimensional information which is plotted into the 2-dimensional figure. The x-axis shows that normalized geopotential height at 500 hectopascal over the North Atlantic. Y-axis shows the spatial coverage in terms of percentage, and the color bar represents the ECA, the event coincident analysis, coincident triggering rate between the wave number, respective wave number versus the geopotential height at very high anomaly. It's greater than 1 standard deviation. So then we can see that if more than 0.5, which is shows in the orange color or red color, that is giving the high teleconnection, or you can say like a high event coincident which is happening together. That's a Rossby wave 7 and 9, as well as the very high anomaly over the North Atlantic region of the geopotential height at 500 hectopascal. Inside that, numbers are shows that the ratio between the probability of Rossby wave versus non-Rossby waves period. So which is greater than 1 shows that it is very high chances to have this kind of event when the particular Rossby wave is occurred. And also the dotted white circle shows that 95% significant. So overall, we can see that like a Rossby wave 7 and 9 shows that a very high chances or a high probability to get the geopotential height at 500 hectopascal or blocking over the North Atlantic region very high. The similar relationship also seen in the Rossby wave 4 to 9, which is not shown here. And this is the like similar study for the different Rossby waves, but over the Indian heat wave. Like this is heat wave plus severe heat wave category for the Northwest India. X-axis shows that weekly average maximum temperature, which is already categorized for the heat wave and severe heat wave category. Like we can see that Rossby wave 6, 7, 8, 9 are represented. Like here we can see that at least like 30% of area, like Northwest India, 30% area are directly influenced or teleconnected by these respective Rossby waves, versus the weekly average maximum temperatures more than like 42 degrees Celsius. And we can see that Rossby wave 7 and 9 are the most ECA, that's event coincident rate analysis triggered, and next most is Rossby wave 6 and 8. So this is like a past study or is the recent historical. What would happen in the next, the future plus 1.5 degree or 2 degree warmer world? So we are using the model output from the HAPPY. That HAPPY is a project like half a degree additional warming in prognosis and projection. So it is having three experiments, namely historical 2006 to 2015 and plus 1.5 degree and 2 degree, all of them having 10 years period. And these are the 5 models. all of them having more than 100 ensembles in the each experiment, and all the model temperature and geopotential height are being bias corrected. Just two more slides. So this is the 5 models individually plotted. Here also, like how these events are preceded the Indian heat waves or preceded by the geopotential height over the North Atlantic region at 500 hectopascal. The brown shows that historical event, historical ensembles, and the blue shows the plus 1.5 degree, and red shows the plus 2 degree warmer world simulations. All individual dots are individual members. The circles are showing the mean. So we clearly see that both the mean of the total events as well as the standard deviations are increasing towards the plus 1.5 degree and 2 degree. Like it's more than like a 10 days, when historically it's like about 5 days, and plus 1.5 degree shows around 8 days, and plus 2 degree warmer shows that average of like 15 days event. So a longer duration heat waves would be happening in the future. And this is the Rossby wave frequency versus probability. Like Rossby wave 4 to 9 are shown here. X-axis shows the different individual models March, April, May, June, and the last one shows that as a season. The blue bar shows that historical, and orange one plus 1.5 degree, and red one shows that plus 2 degree future. This y-axis shows the probability, and here it shows the frequency. We can see that the probability of to occur Rossby wave, like all like 4 to 9, are increasing in the future, especially in the March and April. You can see that like in March historically is very less, but the future plus 1.5 degree plus 2 degree are increasing March and April, whereas in May and June out it's declining. So in the net, the season wise the Rossby waves are not changing, but in the individual months earlier, like March and April, the respective Rossby waves probability is very increasing. This is the final results. It shows that here we are comparing the temperature over the northwest India versus the probability density function with respect to the individual Rossby waves. Here we can see that like suppose Rossby wave 9. Here the blue line shows that historical experiment when it is Rossby wave occurs during March to June, and the orange shows that plus 1.5 degree orange line, and plus 2 degree shows that it shows that in the future the future warmer world are getting increased for the lower temperature threshold but higher probability, which also suggests to the decline, suggesting to the towards the earlier occurrence of heat wave during March and April. But overall, that temperature is not increasing. Though in the future temperature may not increase, but the duration and early occurrence will increase. So these are the key points which I thought to present. Thank you.
Thank you. Any quick question? Okay. If not, then all the speakers will be available in the breaks and this thing. So I thank speakers. So next, I think there will be felicitations for the speakers, and I ask Asha.
Thank you, Dr. Ajit Tyagi sir and Dr. Rajiv Chattopadhyay sir for chairing and co-chairing this session. Now it's time to felicitate chair and co-chair of this session as well as the speakers. So for that, I would like to request Dr. Kumar Kolli, President, IMS National Council, to please come on the stage. And first, felicitate chair of this session, AVM Dr. Ajit Tyagi sir. I also request Dr. Rajiv Chattopadhyay sir, so please come forward. After this, I would like to request our first speaker of the session, Sri S.C. Bhan sir from IMD New Delhi. Next speaker of the session, Professor Rajashree Kotharkar from VNIT Nagpur. Dr. Abhiyant Tiwari from NRDC, New Delhi. Next presenter, Mr. Raju Mandal from IITM Pune. And last speaker of the session, Dr. Arulalan T from IMD New Delhi. Thank you so much, everyone. Now we are going to start our next session. So to chair this session, I will request Dr. Kumar Kolli sir, along with co-chair as a co-chair, Dr. R.K. Jenamani sir from IMD New Delhi.
Thank you, Asha. So thank you for the opportunity to support this session 2. We are actually already behind the schedule by close to 25 minutes. But in order to keep you on time for lunch, we have made some arrangements. At least one talk is cancelled and one talk was shifted to the next session. So in all, we have 3 presentations in this session, 2 keynote talks and 1 contributed presentation. So without wasting much more time, I invite the first speaker, Professor Purnamita Dasgupta from the Institute of Economic Growth to present her keynote talk on assessment of heat health risks and economic impacts. In fact, I have come into contact with Professor Dasgupta only recently, and she is leading a passionate group on the economic and health impact assessment of heat waves. And I am supporting her team in dealing with climate information. So in that, as part of that, I am also part of the authorship that she is going to present. And it's very important for us to look at the heat wave aspects from that point of view in terms of economic and health impact assessments. Professor Dasgupta, you have about 20 minutes, but try to complete by 15 minutes so that we are not too much delayed for the lunch.
Thank you. Thank you for that introduction, Dr. Kolli. My thanks to IMS Pune chapter, IMD WISE, and IITM Pune for giving me this opportunity to be here and to share some thoughts on the work we are doing. So a lot has already been said. I will try to focus on some key aspects of trying to assess heat health risks and their economic impacts. The idea is to be able to delve a little bit more into the three stages of this relationship, from going from heat to health to their economic consequences. Um, is we, as we have already heard, that there has been a mushrooming of literature around trying to understand excess mortality associated with heat. And most of this, the starting point is how we look at heat. And today we are fortunate that we do have in India also some good publications from the Ministry of Earth Sciences. We have forecasts from IMD, and I think a lot of interest has been generated with the WMO, WHO guidance, and with NDMA coming in, trying to, the adoption and implementation of heat action plans, which are naturally at different phases for different states. But overarching through this narrative is what I would say a societal, trying to realize the societal value of reducing risks to both the economy and to health, both of which are framed and seen as totally preventable. So that's the part that anchors this whole narrative across heat, health, and the economic consequences, that these are preventable. What can we do to reduce them? At one end of the ladder, at one end of the stream, and the upstream part of it is how do we get the best heat measurements that can feed into understanding health and economic consequences. So having said that, let me just share what we already know very briefly. So within the current studies, which have focused primarily on excess mortality, I would first like to bring to your attention that there are two sorts of studies, very broadly speaking. One set of studies actually looks at how annual deaths behave with temperature variations across the year. And there is another set of studies which, broadly speaking, focus on heat wave related deaths. So these are two slightly different things. And in India, mostly so far, we have seen the excess mortality being mapped with deemed crisis situations such as heat waves. But increasingly, what physiologic literature is telling us, I won't go into the details, but if there's interest, we can speak about it later. So essentially, the ones which are talking about looking at how death rates vary with variations in temperature over the years are looking at how the death rate per 1 lakh or whatever you take it varies when temperatures vary by a little bit, defining different temperature bins. By how much would you expect to see an additional death? And they can define, and then that is defined across the entire range of variation over whichever city or country scale that you're looking at. Economists have tried to model this using various types of techniques. There are some which don't come from economists, but very in a positive direction come with sort of combinations of meteorologists, public health researchers, statisticians, and econometricians. And there are a range of models that have been used. So there's a lot in the literature out there. And one of the first things that you notice is that some of the best comes out of models that actually look at the IMD daily gridded data. And so I'm going to keep coming back to that and the importance and relevance of this data for work that is being done. And this data, because we know it is available from various other sources also. As someone who started looking at the data, I will share with you some of the things that an outsider to the system runs into when we look at this data and try to analyze it. Similarly, when we look at health, there has been a focus on excess mortality, which is very valid because mortality is the most extreme form of the health effect. But increasingly, public health experts have been putting together evidence and warning us of a host of what they call other pathways through which health impacts are felt and which are becoming increasingly important, whether in terms of outpatient visits, inpatient admissions, and so on. So what we have conventionally understood as age, say for elderly or children, or what we have understood as the typical heat-related illnesses like HRIs, like stroke and all, are now being looked at in a slightly different way. What is coming out, just like in the context of heat and economic consequences, is the importance of feedback and iterative mechanisms and being able to put them in place. So there are a whole host of illnesses which are pre-existing and which actually get exacerbated due to heat. There are also illnesses which people are finding evidence on, which get initiated or triggered, such as kidney diseases, due to a heat wave, but are not manifested during that heat wave and could get manifested even 3 years down the line. So the narrative is getting more complicated, but also the narrative is bringing out a demand for focusing on morbidity and to see interactive effects with heat. I'm going to move on. Therefore, to say that if this is the case, then the consequences of health hazards due to climatic change or heat waves actually moves through several layers. So of course, there's morbidity and mortality concerns with individuals. It also has implications for health systems in terms of their planning, their operations. It has implications for costs, for the economics, not just in terms of damages to health and infrastructure, but also putting in place the additional health infrastructure that one may need for coping with the health effects. It also means putting into place policy instruments such as insurance policies, which have cost implications. It has implications for meeting the investment needs of science, R&D, and so on, for facilitating good management. And of course, we know about the social costs. Now, coming quickly to the economics of heat. So this is a graphic adapted from the IPCC. So I thought I would talk about this just to help us walk through it. So one initial incident, if we start from the left top corner of the graphic, from increasing heat and drought, leading to heat stress. So this is just one pathway. An increasing heat and drought incident could have multiple other pathways to heat, but how the economics comes in, from heat stress among farm workers, leading to a host of health impacts, which brings treatment costs, prevention costs, and a whole lot of costs to those impacted, leading to economic costs also of drought, heat, reduced crop yield, which we have heard about, reduced productivity for even those who still may be reporting to work, but at reduced productivity, to increased food prices, reduced household incomes, all of which could be at local level, but it could also potentially have global impacts. And today, I can share with you that entities like the Reserve Bank of India are thinking about how to carry this forward because inflationary impacts is a big concern. Similarly, we have seen recent years trade regulations, trade restrictions coming in due to impacts on crops. So it's really an extremely interactive kind of thing that is going on. And as an economist, at least, I'm very happy that that a more holistic view can be taken. Of course, where in the whole narrative, the important part is to understand that what comes out of this from expert minds, such as those gathered in this very esteemed audience, marks the floor or starts the narrative for many others like me who join this narrative more downstream once you've got the heat in. But then we would like, of course, the space to be heard back and feed into the way heat is looked at and understood. There are many economic impacts of heat. As I said, from monetary policy to fiscal policy, a lot of other interests are being generated, even if you look just at heat health, because heat health gets embedded throughout the chain. Let me carry on. There are many methods for impact evaluation that have correspondingly come up. Some of these have existed in the world of environmental and resource economics for a long time, some within health economics. But now these are just starting to get implemented in the context of heat. In a study that Dr. Kolli just spoke about, which we are trying to do a cost-benefit analysis, and we will try and do choice experiments to understand how communities adapt to heat and move on to understanding it. I won't talk about the study, but I would just like to say that we are a team of climate scientists, health experts, economists who are trying to sit down and unravel the complexities. We are in a learning mode. We are happy to talk with you and learn from you. If you have thoughts to share or want to engage with us, we're very open to that. One of the key ideas is, of course, the access to climate data. Now, what we have learned, and thanks to Dr. Kolli to a large extent, is that IMD data is the best data. It is the base data, but it also becomes available from other points, like NOAA. And for someone, and what we noticed is that in recent years, there were a large number of papers published which said they were using NOAA data, not IMD data. And this intrigued us. And we started probing on this, looking at what the NOAA data looked like. And depending on which sort of data one was accessing from the NOAA website for the stations, weather stations in India, one could get different types of ways in which missing data had been filled in. There was some very curious kinds of observations, and that set us thinking, going back to the drawing board, trying to see what was happening. And in the process, we did just so much appreciate the importance of access to good and quality control data. We then moved on to using Climpact software, which is a WMO product. And this brings me to the next point on why I'm talking about this. Of course, previous speakers have also touched upon it, but I would beg your indulgence to speak a little bit more about what we think is important from the perspective of health and the economic consequences, what we have figured out so far. So there are a host of indicators by which the impacts of heat on health have been defined. And even when you look at heat waves, there's a wide variation in how heat waves are defined. What are the underlying criteria that are used? And many of these, depending on the kind of definition one uses, it speaks to a particular health impact or it speaks to a particular economic impact better. It also speaks differentially to different places. So for example, physiology, the health researchers tell us, we've chosen two sites, Bhubaneswar and Jodhpur. So public health researchers tell us that physiologically you would expect to see less deaths in Jodhpur, even if Tmax is much higher, because the periodic heating and cooling cycles that the body goes through has an impact on the mortality and the morbidity you would expect. Whereas if you go to Bhubaneswar, where you do not see the same amount of diurnal variation, you would get, for the same temperatures, much higher mortality. So the importance of how we define a heat event and the consequent heat stress and heat strain, as the medical fraternity defines it, can be very well linked to the way one is defining heat. I will just move on a little bit to show you what else that means. So we've been trying to do this through data for Jodhpur and Bhubaneswar, putting in the red, orange, yellow alerts that we have heard of earlier. And depending on the time slice, we find that one would have very different ideas of whether heat waves are going up or going down in India. This is something we also deal a lot with in economics, because we see huge issues of non-stationarity. And there is a difference among at least modelers on our side of the table, where we struggle with whether we use averaging to smoothen a series. There's a committed group there. There's another equally other committed group which focuses on a lot of modern techniques on identifying outliers. As we know, climate data has wide non-stationarities in it. So finally, just to end, so these were some of our forays, I would say, because we are, as we say, in initial stages into looking at data. So here's Jodhpur. If one looked at Tmax, which is the lower panel, it becomes very clear that Tmax, was increasing 2012 to 2014. If you look at the upper panel, that is the minimum. You can see that there's a very different trend. So what one reads off can really matter. So in terms of heat wave indices as well, what are the most relevant indices is a conversation that I think we all need to have with meteorologists and gain from them, learn also on what kind of differences it makes on what are the underlying criteria we're using, whether it's in terms of numbers, frequencies, duration, amplitude, magnitude. We get very, very different kinds of patterns if we look at the Jodhpur data, for instance. So I will end here. I hope the presentation wasn't very fragmented. Let me just say that as we track this journey from heat to health to economics, we are mostly probing on the heat side right now. And thank you once again for inviting me. It's been a big learning already. Thank you.
Thank you very much, Purnamita. I know we are short of time, but I can take one question if anyone has.
Thank you, madam. Nice presentation. I just have one quick question. So when we are talking of economic impact, then how do you think this temperature-based measurements are important, or the other indices which we are talking? So you need any other derived indices from meteorology, or just the temperature would be sufficient, as you are showing here in the last plot, like stationarity and all those things? What you need from meteorologists? Actually, that's my one question.
We want meteorologists to tell us what we should need.
Okay.
But more importantly, I think what we have initially understood is that it's a challenge to sort of, deal with these different layers. So what we really need is perhaps access to quality controlled met data across stations, because looking at historical observations also helps a lot, because when we start modeling the economics part of it, doing our econometric modeling, the derived indices start becoming important. Tmax, as we saw in this case of Jodhpur, when we get into the heat data, if we are happy, if we were just happy with just looking at the max or just looking at whatever is already available in terms of in the public domain, as several other studies have done, then it wouldn't be perhaps an issue. But when we start getting into the data and looking at the gridded station-wise data, we realize that there's a lot inside it. And, for example, I'll give you a short example and end. The question of relative humidity. So the public health people are saying that relative humidity does not act unilaterally across different areas. So they are saying, for instance, relative humidity could be an offsetting factor in the case of a dry climate like Jodhpur, whereas it could be a reinforcing factor in a place like Bhubaneswar. So therefore, the derived indices also start becoming important. But if I went downstream and started my economic modeling on the basis of, and the costing, trying to take out the costing on the basis of just one type of index, the moment I use a different index, I get a completely different result. Yeah. So your help would be instrumental.
Thank you.
Thank you.
Thank you. You can see that the same data can give different answers depending on how you actually use it. Okay, now we go to the next presentation by Professor Mahavir Kollacha from Institute of Public Health, Gandhinagar, on India's heat action plan.
Yes. Thank you very much, IMS Pune's chapter, IMD, and IITM for have invited me to this symposium. And I think before lunch and after lunch session are always harmful for participant, and I'm unfortunate that I have always been given such session. And I can see many of the participants are eagerly waiting for lunch. But believe me, I'll finish on time. I think I have been allotted 20 minutes, but I'll try to finish before this. So as already mentioned by previous speaker like Dr. Bhan, Abhiyant, and they have also talked about the Ahmedabad Heat Action Plan and why this Heat Action Plan is a successful public health intervention for saving lives, livelihood, and economy. So I'll discuss in detail. So this is one of the important slide I always show wherever I go for talk. If I'll talk about 10 years before, if whenever we were going to the municipal corporation, if Abhiyant knows this, when we talked to municipal commissioner that we need heat action plan, so they said, oh, heat can't kill our people, heat is not killing our people, heat is not a major issue. Oh, people are feeling heat, it is causing discomfort, but heat can't kill. But when we looked at data and when we correlate it with the temperature, and then we show them the graph, and they realize that definitely heat is killing our people and we need heat action plan. And estimating the public health impact of extreme heat is very difficult because public health authorities largely in our country are not reporting heat related mortality and morbidity, although NCDC has recently started heat health surveillance system and they have implemented, but most of the public health facilities are not reporting the data. And that is very important. All heat related deaths and illnesses are preventable and avoidable by efficient mitigation and adaptation planning. And saving life from extreme heat is low hanging fruit and highly cost effective, as already mentioned by previous speaker. And I can assure you, as a health economist, if we will invest $1 in heat action plan or reducing impact of heat on human, we are definitely getting more than 100 time returns. I think this has already been covered this year. Already IMD has predicted the temperature would be above normal this year. Yeah, so you can see already Dr. Tyagi has mentioned in the morning that we have already crossed our target of 1.5 degree in this year already. You can see this is last year data from NCDC. Many state has reported heat stroke cases, and in the Uttar Pradesh, as mentioned by Dr. Bhan and Dr. Tyagi, we have more than 100 deaths in Balia district of Uttar Pradesh last year. Already so it have huge socio-economic impact not only on human lives but livelihood and economy has already been impacted. According to the Lancet, India alone lost close to 75 billion labor hour in 2017 due to extreme heat, and India is going to lose more than 5% of its labor productivity by 2030 if temperature is going to cross 2 degree centigrade above normal. So you know that in the year 2010, the many of Indian cities has experienced severe heat waves, and the Ahmedabad, the city situated in the Gujarat, and Nagpur has has experienced the severe heat wave, and there was loss of mortality due to heat wave. In response to that, there was a in the city of Ahmedabad in the month of May, there was a outcry everywhere. There was an ambulance in the ICU ward. In 20 bedded ICU, there were more than 40 patients. NSI neonatal ICU was also full. So there was so outcry among the population, and that has alerted the municipal corporation, state government, and national authority that we need to do something about this. So then the Indian Institute of Public Health, Gandhinagar, comes to in picture, and the IIPH Gandhinagar has collaborated with the NRDC USA, and we have started discussion with Ahmedabad Municipal Corporation, state government, and like-minded institution for basically developing a public health strategy for reducing the impact of extreme heat on, especially on the population. So first we talked with the Ahmedabad Municipal Corporation, and believe me, it is very difficult to, we are fortunate we have IMD like organization. We can have more than 50 years of temperature data, humidity data. But if we'll go to any municipal corporation in India, any district in India, you'll not get health data of more than 2 to 3 years. It's very difficult to get health data. I'll talk about the London. They have started providing mortality data in 16th century. But if I'll talk about India, I can say hardly we got data from 4 to 5 municipal corporation about health related mortality and morbidity due to extreme heat or be it any cause. So with our continuous effort, we got the data from Ahmedabad Municipal Corporation, and you can see on the particular day of 21st May, there was a 310 death in a single day. If I'll talk about the city of Ahmedabad, at that time the population was about 5 to 6 million, and considering the population of 5 to 6 million, every day about 100 to 110 people dies in the city of Ahmedabad. But when there was a severe heat wave in the month of May 2010, and on particular day of 21st May, there was a 210 additional death, and in a particular week there was a 800 additional death in a particular that week of May 2010. Then we have got the data from IMD, and we have correlated with the temperature. So what we have seen in the year 2009 and 2011, the above the average temperature was not exceeded more than 43 degrees centigrade. But in 2010, on a particular day of 21st May, the temperature exceeded 47 degree centigrade, and there was a additional mortality. So this particular graph, and I can say with confidence that if we would not have produced this, we would not have heat action plan journey at that level that has given, impetus to the heat health journey in India. Based on the Ahmedabad heat action plan data and this, analysis, the NDMA has developed a national guideline for developing heat action plan for Indian cities. So you can see from the year 2001 to 2016, the maximum mortality in the city of Ahmedabad was in the year 2001 when we have heat earthquake, and after that again in 2010 and then in 2016. So you can say heat is one of the important disaster causing loss of lives in the city of Ahmedabad, and second most disaster in the city of Ahmedabad. And if we will, carry out the analysis of data in most of the Indian city, heat would be definitely one of the important factor for excess mortality and morbidity in Indian city. But unfortunately, we are not having health data, so we are not been able to carry out analysis properly. This is one of the important example I would like to cite for basically mitigating the impact of extreme heat on neonates. So in Ahmedabad, we have one hospital for basically children's. The fact is that in the year 2010, there was more than 4 times admission in NICU due to extreme heat, and the NICU was on top floor. Okay, so top floor got most of the heat. So there was excess death on top floor. So we have basically, as a solution for mitigating this impact, we have shifted the ward in the lower floors, as well as we have done the cool roofing through China mosaic. So in subsequent year, there was significant reduction in mortality due to extreme heat in neonates. No sir, 20 minutes थे sir, अभी 10 minutes ही हुए. So with the partnership IMD, NRDC, University of Washington, we have developed and implemented the Ahmedabad Heat Action Plan in the year 2013. And there are basically 4 key components of Ahmedabad Heat Action Plan that has already been talked. So one of the important component is early warning system and implementing and disseminating. Early warning system, IMD was already giving us, but how to basically implement the early warning system with the support of interagency coordination and collaboration, coordination and cooperation with various stakeholders, that is very important. So we are getting data, early warning data of 5 days from IMD, and we have developed a interagency coordination group at various municipal corporations, and they have disseminating to the education department, electricity department, water department, that when there is going to red alert, orange alert or yellow alert. Then second component, and I can say that this is the one of the important component over of 1 decade of our experience. The public education and community outreach is the one of the important component of heat action plan. If you will do this properly, effectively, efficiently, you can save lots of disease burden on health system due to extreme heat, and also save lots of life. Then capacity building of medical professional. Initial year, Abhiyant knows most of the medical officers are not aware about what is the basically difference between heat stroke and fever. So how to treat fever and how to treat heat stroke is the approach is totally different. So we have to educate, we have to building the capacity of the medical professional that how they should deal with heat related illnesses. And finally, reducing heat exposure and promoting adaptive measures. So this is the impact of Ahmedabad Heat Action Plan. I already mentioned that in 2010, we have reported cases of heat stroke 274 and 65 reported death. The death was much more than this, but reported that due to heat stroke was 65. In 2013, we have implemented the Ahmedabad Heat Action Plan, and in subsequent year, you can see significant reduction in, although temperature is rising more than 2010. In 2016, we have more temperature than 2010, but number of heat stroke cases were less, number of heat stroke deaths were less. Significant reduction in mortality and morbidity due to heat stroke. And this has become the successful template for many Indian cities as well as many low middle income economies for developing a cost-effective heat action plan. This has got global recognition cited by IPCC, WHO, WMO, United Nations, etc. These are some adaptive measures and very easily implementable. Water distribution point in vulnerable areas, cooling centers, change in school time. I think I still remember Roxy has pointed out this point in NDMA meeting that we should basically close school during heat, May and June. Stoppage of heavy construction, implementing heat safety measures, revision of national building code. Still, I can say that in India, still the cool roof and heat resilient building, it is not in national building code. So most of the affordable building are developing without any heat safety norms. You can see cool roof. Abhiyant would be somewhere in some other tin roof. And then the riverfront, reviving the water bodies has great impact on reducing, heat by 2 to 3 degrees centigrade. And then urban forest. I think there are sectoral specific, like collaborating with NGO. I want to give this example. In Ahmedabad, we have collaborated with the religious organization, like we have Jain community, Bora, and Swaminarayan community. We just tell them that on the red alert day, please provide buttermilk and water at various bus stop, and they are providing this. That has had great impact on reducing the impact of heat on population. Education department changing the school time or basically closing the school during heat months. Yeah, that is put wall mount, in ICDS Anganwadi, you can put simply temperature showing clock. So the Anganwadi worker would be aware that today is hot, so they can give ORS to the children, they can give ORS to the pregnant woman. They are the more vulnerable. So simply, because they will not know heat alert kab hai, kya hai. So simply you will inform them wall clock is there, they will show the temperature, and they will be given instruction, if it's 45 degree, please give to ORS to the children's. What? Yeah, these are some of the best practices. Cool roof I have already mentioned. Green cover, this is a study from Barcelona Institute of Global Health. If you will increase green cover by 1/3, you will reduce heat related mortality by the 1/3 due to the effect of urban heat island. There are heat resilient health facility framework developed by the NCDC. Key takeaway, heat-related deaths and illnesses are preventable, avoidable with proper public health planning, mitigation and adaptation measures. We can, reduce economic losses due to less labor productivity. We need to understand the link between climate change, heat, and health, and also impact of heat on human health. One of the important strategies, public education and mass awareness, which is highly efficient and effective. We have to work and commit to develop and implement a state and city action plan, which will require action from online department. And I don't want that. This is the benefit of heat, but we don't want this. We really don't want to save our LPG. And this is घर से निकलते white bread, and then we become brown bread when we return to home. Thank you very much. This is our publication, you can cite.
Thank you, thank you. So all the heat, what action you need, you can imagine. So that is the heat action plan. So any one question you can take, and particularly as you know that they are doing for last many years. He has shown the credential also, and you must agree with it, or of us also. Any one question, anything?
Challenges for implementing heat action plan?
Yes.
There are many.
Just one.
Just one is governance and leadership. Most of the, I can say I have visited more than 40 to 45 municipal corporations. And I have got data from only 4 municipal corporations across the country. Rajkot, Nagpur, Ahmedabad, and now we are trying to have in UP. Rest, most of the municipal corporation, either they don't have, or they don't have system of recording the data, morbidity and mortality due to heat wave, or they don't want to provide it.
No, already we are late. Please go. We will go for the next talk. Then, if time permit, we can have a discussion. So please, because yes. So till he takes that stage, I will give you one point only, that heat wave, any action plan is really lot of cost needs. साइक्लोन आदमी को बैठा दो 2 दिन के लिए ले जाओ, लेकिन हीट के लिए 15 दिन you need 3-4 districts. I mean, you just imagine how much money you need, right from addressing health, water, cooler setting, you have to put mass cooling. Canada, they did, It's a lot of work to be done, and India is just starting actually. So next talk is by our IMD, Radheshyam ji. He will take 8 minutes and 2 minutes per question.
Okay.
Thank you.
So, good afternoon, everyone. I will be trying to complete within the time frame. Today, I will be talking about the spatial and temporal variability of the heat wave and extreme maximum temperatures, especially over Rajasthan, with special emphasis of the exceptionally hot summer season 2022. So, as we all are know, Rajasthan is well known for the extreme hot and dry weather condition, especially in the pre-monsoon season. So here in this study, we have utilized the more than 50 years daily maximum temperature data of the IMD for the 10 stations for Rajasthan. We have analyzed the frequency of the heat wave, then extreme maximum temperatures, especially the decadal variability to analyze the spatial variability of the heat wave. And then in the exceptionally hot summer season, to analyze the atmospheric situations, we have utilized the ERA 5 data, reanalysis data, to evaluate the atmospheric conditions for the year 2022. So this we have already discussed that in this study we have utilized the IMD criteria to identify the heat wave conditions. You can see this is the mean frequency of the heat wave, especially in Rajasthan itself. So it is very interesting to know that the mean heat wave days in the month of March are very less. It is 0.2 to hardly 1.5 days during the last 50 years. While if you see over the coefficient of variation in the month of March, it is very high. So it itself represents that the frequency of the heat wave in March is very variability is high. So apart from this March, if you look over the month of May, so it suggests that the mean frequency is very high. However, the variability in the frequency of the heat wave is very low. So that means it is observed in the many of the years that in some year there is no heat wave in March. However, in some of the years there is a high frequency of the heat wave in March. Mainly, we concentrate the heat wave in March because it indicates the early onset of the heat wave or the hot summer season also, which may leads to the extended period of the summer season. And also, if like in the 2022 year, the heat started from the February itself, so that might have adversely impact over the Rabi crop, because in the Northwest India, it's a stage of the cropping, the Rabi crop basically. So coming to the frequency of the heat wave in March and April, so one can see at many of the stations indicating the frequency of the heat waves are increasing, especially in the recent 30 years, the frequency are increasing. And one can see in the panel of the red arrow. So the year 2022 represents that the record break heat wave frequencies, especially in the March, and you can see in the month of April also. So 2022 I have selected because it was a very exceptionally hot summer season. Coming to the month of May and June, so again it is observed that the most of the stations are indicating the frequency of heat waves are increasing, and also except one or two stations in the month of June, because nowadays in Rajasthan especially, the pattern of the onset of the monsoon has also been changed. So compared to previous practice, the monsoon onset is advanced by the around 1 week. So this might have also correlated with the frequency of the heat wave. So now coming to the decadal variability of the heat wave in during the March and April. So you can see the left one panel of the image represents the recent 5-decade variability of the heat wave, especially in Rajasthan. So it is very interesting results we are getting, that in the 2001 to 2010 and the recent decade 2011 to 2020. So it is observed that the heat wave prone zone is observed somewhere over southwest part of the Rajasthan, and comparative to the 4 decade back, it is observed the frequency of heat waves are increasing by 3 to 4 times more than the earlier decade. Similarly, in the month of April, the more heat wave prone areas are shifting towards the northwest Rajasthan and some parts of the northern Rajasthan also. Here we have not, it is not observed much change in the frequency of the heat waves. Similarly, in the month of May and June, so the mainly the heat wave prone zones are concentrated over the northwest part of the Rajasthan. Coming to the extreme temperatures, so again it is observed that most of the stations are indicating during the last 50 years the extreme temperatures are rising. And if we look over the particular month, so around 90% of the stations are indicating the increase in the extreme temperatures in the month of March. That is very significant signal for the onset or the early onset of the summer season. Now coming to the exceptionally hot summer season 2022. So if we look over the actual observation of the year 2022, so the first spell of the heat wave was started somewhere from 15th of March. You know, today it is 19, and at that time the heat wave was already started in the Rajasthan. And the extreme maximum temperature 43.4 degrees Celsius, which was above normal by 7 degrees Celsius, was observed on 18th March. I mean, as we compare the yesterday temperature of the Badmer was around 35 to 36 degree. Now coming to the during this season, it was the 44 consecutive dry days. There were not at all rain during this period. And so if we talk about the La Nina or El Nino, so during the 2022, it was weak La Nina conditions. And during the initial phase of the summer season, it was expected that the temperature might have observed below normal or near normal temperature. But the apart from the weak La Nina conditions, it was exceptionally hot season. And if we talk about the number of frequency of the heat wave, in the month of March itself, it was around 15 number of days was observed. Similarly, in April, it was 21 number of days were observed over northwest part of the Rajasthan. Similarly, in the month of May, slightly it reduced, but still, or the western part of the many parts of the Rajasthan, it was observed 15 number of days heat wave. Now, coming to the surface, this is what we have analyzed. The atmospheric condition basically responsible for the abnormally high temperature conditions. Here we have utilized the ECMWF ERA 5 data, and we plotted, okay, sir. So we plotted the wind and temperature anomaly in the 3 different atmospheric layer. Number 1 is the lower level, which is 850 HPA, then middle troposphere, and then upper tropospheric level. So this is our findings. We have observed here that the temperatures are observed 3 to 6 degrees Celsius above normal over the many parts of the West Rajasthan and adjoining Pakistan border area. And the lower tropospheric level wind pattern is also indicating there is a clear cut. You can see there is a clear-cut anticyclonic flow was developed over same area where it was above normal temperature conditions. Similar conditions was also observed in the April also, but in the May and June, if we compare, so that anticyclonic flow was not that much responsible. However, the strong easterly winds was prevailing over the northwest plain area. So now this is the atmospheric conditions in the middle tropospheric level in the 500 HPA. So again, you see it is a very prominent feature we have observed, especially over the same region. This anticyclonic flow slightly shifted from the western part of the Rajasthan to the western parts of the Pakistan and adjoining region. So it means that the anticyclonic flow which was observed in the lower level, that was also persisted in the middle level also, and that might have leads to the high temperature conditions over the region. Similarly, in the April, you see, Okay, similarly, in the upper level, in the 200 HPA, it was also a similar kind of situation. So this is all what I have already discussed about this. So thank you very much, sir.
is the highest heat wave days over Rajasthan.
Especially in Rajasthan,
March,
sir.
April, May. And North Rajasthan is increasing. And one question, what is the role of a Indira Canal that water? People are telling it is playing, more thunderstorm and something. Yeah.
Sir, actually, West Rajasthan is a arid region, and it might have some role of the Indira Canal or the West Rajasthan in view of the supplying of the water for their daily basic needs. But I don't think the canal has a large impact over the atmospheric conditions because this is a very the water availability is very limited. Actually.
Thank you. So
All right.
Thank
you very much.
Dr. Radheshyam Sharma for his excellent presentation. And as you have seen that this session has been very much, all the presentations are excellent, and particularly the first was on the economic impact. And then, as usual, you have a, Indian Institute of Public Health from Ahmedabad. They have been working for a long period. But only our request is after 2010 Ahmedabad, heat impact, not such analysis has been made as far as the heat impacted death is concerned. So you can imagine if we could not do any work after Ahmedabad, that 2010 death, any graph we could not generate. 2015 had so many deaths. 2019 had so many deaths. So how can we do a heat index for India? So that is the status. This is not IMD or any other organization, but that is reality in India. We don't get the data. We cannot complain to each other. We have to sit each other. So that is my message actually. So, so thank you. I will give to organizer. Yeah, thank you.
Thank you so much. Now, I would like to request Dr. A.K. Sahai sir to please come on the stage and felicitate chair and co-chair of this session. So firstly, I would like to invite Dr. Rupa Kumar Kolli sir. And co-chair Dr. R.K. Jainamani sir. Now it's time to felicitate our speakers of the session. So for the first speaker was Dr. Purnima Das Gupta from Institute of Economic Growth, New Delhi. Yes, sure. Next speaker is Professor Mahavir from IIPH Gandhinagar. And next speaker, Dr. Radheshyam Sharma from Med Center Jaipur, IMD.
I am very much worried कि कब काम करेंगे, so that people, the impact will reduce. Hottest area का राजा राजस्थान.
So I'm thankful to everyone. Now we are having a break for lunch, and we will start our next session sharp at 2:30 p.m. So I request all the participants to please join us at 2:30. Thank you. Actually, we have not received many presentations for our next session. So it is also requested to all the speakers to kindly copy your presentation in the system during the lunch time. Thank you.